where the mountain.
But just real quick, from Dr. Mike Heffron's original presentations from more than a year ago, he did say that refraction, the atmospheric refraction, would not change the time of occlusion, but that position is slowly changing. I think Alan finally agreed that that actually is wrong. Shane, I'm not sure about yet. And that's where some of the confusion is.
What?
Originally, Dr. Mike Heffron said the time of occlusion is not changed by atmospheric refraction. That's why it was safe for him to ignore. And that's what his original presentation was a concept.
You have a timestamp for that? They're all on YouTube. If you could pull it up, that'd be great. But yeah, Ken, I wanted to talk about the things that you were touching on to kind of clarify on them.
Yeah, go ahead.
Okay, so in referencing to true position and apparent position as the flat Earth position, like obviously we only ever are referencing the apparent position. That's all anyone's ever seen. The true position comes out of the two sphere model, which is the celestial and terrestrial sphere, where the stars move at 15 degrees per hour for their true position, and then obviously as they get down uh, an elevation angle relative to the observer, they introduce different components of refraction to describe the separation between the apparent position that you see, where it should be if it was following sidereal time perfectly, versus where you actually see it. And as it gets lower, that the timing difference increases. Okay, so originally Mike was saying that we don't need to account for refraction for the observation between us and the mountain peak, and that was the original claim. And that still stands, because the only thing that we care about is when the occlusion happens. That's the position that we've always had and maintained. When the occlusion occurs, we don't care how much refraction there once was, because it's no longer being lit, it's no longer being refracted, and it has thus been occluded. Then that's when we start referencing true positions for timing differences. Okay, so much like how they have a system for comparing angles in time for apparent positions and whatnot for how much refraction there should be, we're going to do the same thing, but we're going to independent thing. We're going to feature a mountain peak of a known distance and elevation away from us. And when we do that, when we compare those timing differences, there's a direct timing difference that should occur between flat Earth and globe Earth, because the celestial sphere links the terrestrial sphere one to one, and it's all linked to sidereal time through the true positions. If you know the time of, if you know what your local time is, you know where the star's true positions would be. So you have the ability to reference that. And so, because angles are related to time, any angle, any drop in the sky or distance traversed on the ground are equivalent through time. So that's an extremely important aspect of this, because what we're going to do is we're going to compare angle differences to time. And well, it's really just comparing time to time, but it's kind of easier to conceptualize it, or however it works for you. But in any case, drop over distance, like an elevation difference between us, that creates a timing difference, because the globe, the celestial sphere, two sphere model references a fictitious observer at the center of the coordinates of, which would be at the center of Earth, and that is what creates the lower elevation angle. That's what puts the observer on a sphere. That's what creates their horizon being a tangent on that sphere, and their how much of a mountain is obscured bottom up is a function of their is a function to their distance to the horizon, because that's going to be their tangent on the sphere. So that, like, how much of that distance is between them, well, there's going to be an angular drop between them. Okay, that angular drop is also equivalent to angular drop time in the sky. So we know, if the total arc length to the original Pikes Peak measurement is, let's see, I think it was 27 arc minutes. So if there's 27 arc minutes between us, that's about 2 minutes and 30 seconds of star dropping in the sky. So if a star, if you were to time it, if you were to measure it at point zero and then measure it 2 minutes and 30 seconds later, it would be 27 arc minutes lower than once you first measured it. Okay, so on a globe, the observer, right, because he's on a tangent on a sphere, he's already tilted. So half of that arc length is already compensated for by his tilt on the sphere. And that's what it is referencing to the fictitious observer. That's what lowers the star for its true position. That's what keeps it, that's what binds it to that for elevation wise. So when we traverse that arc length, right, when we reference where the star was at the peak, you know how they talk about, why are you teleporting to the peak, why are you going to the peak? That's where we're instead of referencing the observer, the fictitious observer at the center of the earth in the coordinate system, we're using our fictitious observer to be the independent reference point of the mountain peak where we know the distance and elevation to. And so that timing difference where the star should be when we make our prediction, if the Earth is a globe, the true when we add that arc length back, because we didn't account for curvature, because we just did a flat Earth, a rise over run triangle, we didn't account for any drop over distance. Then the star, when we add that, when we go to the mountain peak and look back, the star's true position should be higher by about the arc by about uh, the drop over distance, because that angle is that timing difference. So when we add that back, we should, because we didn't account for it, the star's elevation should be higher relative to the peak, because the occlusion for the globe should have occurred relative to the observer's position, not relative to the star, relative to the peak, relative to the observer. And when we do the analysis and we do that, we found that we can make a congruent triangle referencing their true positions for the occlusion when the apparent occlusion occurred. So so this hypothesis was in terms of geometric positions. Okay, so uh, when they're like, you didn't account for refraction, well, we did. It's the timing difference, and then when we give the globe refraction, uh, their timing difference, like the amount of refraction that they add back, is always equal to or more than whatever the drop over distance was for the arc length. And in some cases, it's the same amount as the entire arc length itself, which is to say that there's no that it's not dropping over distance. Essentially, it's basically flattening it out when you add the time back, because adding the time back is equivalent to removing the curve. So I hope that kind of clarifies what's going on there with that.
Yeah, I can't get into it as well as you can. I appreciate you doing it. I have a tentative grasp on it, the basics, anyways.
I lost audio, and I don't know if it was me.
Can you hear us, Alan?
We can hear you fine. He must have lost his audio. He might be coming back. Cat's still up there.
I'll check on him, boys. He's got to be around still.
We totally made phone calls to the moon. Uh, you were pretty much finished.
Now we heard you
Right,
fine.
but you didn't use the globe model in your
I
test.
think you asked something about for Ken to answer or something like that.
Oh no, I was just talking about the timing differences and referencing to what and who sees what or whatever. I don't think anyone's ever said that we see the true position. Ridiculous. But we do draw congruent triangles in referencing to where it should be, which should not be possible on the globe. That's our point. Anyway, what were you saying, Doofus?
You didn't test it against the globe model. We're not putting the observer at the center of the Earth. We're putting the observer at Mike's house where the star was seen to be obscured.
Well,
Yeah. So the globe, we're testing the geocentric position of it, the geometric position, the true position, the thing that actually defines where the GP is when you use it. So we are actually doing that, and that's why we go to the mountain and check the true positions with atmospheric refraction off. When you have refraction on, like I just said, the timing difference between the two is basically removing the curvature and adding the arc length back in to make it flat. So we do account for that, and we do compare a flat baseline to a globe. That's also part of flattening the arc length, as part of going to the mountain peak and seeing what happened there. So I'm not quite sure what your contention is.
You're very sure. The place where they saw the star got occluded is Mike's house. The angle that you're concerned with is where Mike can see the star, not where the mountain, or not where the mountain can see the star. Because if you make the argument that the angle from the mountain to the star is the angle that's important, then the angle from the house would have to be equal because you're drawing a straight line.
Yes, and when we reference the star's position and timing through the peak as our independent reference point, we get exactly uh, what the flat Earth prediction is. We get the rise over run of the peak. When you add refraction back to it, if your drop over distance to an arc length is 13 arc minutes, and you add back 13 arc minutes of refraction, well, guess what? Your timing difference is now the flat Earth difference. And you would only know that by comparing it to an independent reference point at the peak. And that's what we've done. So, like I said, the apparent position, the occlusion that we all see, that's great, right? But we're referencing the geometric alignment for timing wise because the globe relates angles to time. And that's what we're testing. And so when we go and do the comparison, we find that the geocentric position of the star is always in alignment with what the flat Earth would predict if the apparent occlusion occurred relative to the peak, relative to the observer, rather than just solely to the observer adding refraction in. Because we can add a correction, in. It's a totally, that's a non sequitur. Like the GG Bennett refraction formula is just geometric angles. It's just polynomials in angles. So it doesn't have any, doesn't require anything globular. It's literally just geometry. So if we were to come up with curve fitting things like that, then yeah, it wouldn't have any meaning. So we are testing the geocentric position of it in reference to the timing that the actual occlusion that we see happens.
Okay. This is going to require a picture since Alan seems to not understand what I'm saying. Ken, you might have to help me out because I replied to the space, but it won't let me share to the Jumbotron. But the angle that you're considering important is the angle from the peak to the star. You have the position that there is no curvature on the Earth, so the horizontal at the peak is parallel to the horizontal at Mike's house. That means the angle from Mike's house to the mountain to the star is a straight line, which means the angle to the star from Mike's house needs to also be 2 degrees, 31 minutes.
Yes, we make congruent triangles with it. That's our point. We shouldn't be able to make it
Right, but it's not.
Okay, you say that it's not, but we've got a ton of showing it. So I don't know I don't know what that means when you're like it's not.
I I think I can give a little clarity because I get these arguments all the time, and so you're going to have somebody like Ruhif come in and say, "Well, if I get my theodolite out at Mike's house, and I measure the angle to the peak, they're coming up with like 2 degrees 18 and a half minutes or something like
No,
that,
he's got it exactly,
right?"
Ken. He's got it exactly. And the diagram.
Yeah,
That is a congruent triangle that we make. That timing difference creates a congruent triangle. That's the exact triangle that we construct. That's in most of our diagrams. That's in a bunch of Shane's diagrams. That is exactly it. They do.
yeah. But the thing is they want to say that everything should be from the observer's position, and but the problem with that is that you're literally testing the geometry of the Earth. The whole point is we know what the apparent position of the peak is through a theodolite. That's not even in question.
Well, that's mixing
What we're saying is what is
entirely.
the
Yeah,
actual
that's mixing it entirely.
position of the mountain peak? And the light is occluded by the mountain peak. Now you're observing it from Mike's house for sure, but what is your angle to that peak? Where is that peak actually at? That's what you're testing. So to say, "Oh, well, you're moving the observer," no, you're not. The peak actually blocked the light.
Yeah, the peak block
What
for the
angle is the
observer.
star?
We're only
Yeah,
referencing the peak for time to see where the geocentric position should be. Because at the time of that apparent occlusion, when we add that arc length back, which means going to the peak to check, the true position should be at an elevation that is equal to or a little more, a little less than the drop over distance should be. as an angle. So if there's 13 arc minutes of drop, there should be 13 arc minutes. That star's true position should be 13 arc minutes above the peak at the occlusion. Otherwise, it makes a congruent triangle, like as shown in the diagram that we've been using and discussing for 42 episodes of Celestial Theodolite.
Okay, but if you use the actual globe position of the observer is at this house and the star's position is determined using stellarium with the observer position at the house and not the peak, and you use the globe for figuring out where the peak should be, at that time, those did actually line up. Those were the same.
Yeah, Doofus, when you reference it where it is from the observer's location, you're inherently referencing where the star's true position should be relative to the fictitious observer. And then, like I said, the refraction condition
It's not a fictitious observer. That's where he's actually standing. It's at his house.
There's no observer at the center of Earth that's comparing where the true position of the star should be for the observer.
You're putting him at the house, not at the center of the Earth.
At the house.
Fictitious observer at the center of the Earth does not exist in this scenario. You made that up.
It exists when you're referencing the true position
how the globe.
Hang on a second, Ken. Doofus, when you're referencing the true position of a star, you are always referencing the fictitious observer at the center of the Earth. When you are referencing,
we're not doing that. We're putting Stellarium's observer.
I'm doing that.
We're putting Stellarium's observer at Mike Heffron's house, where Mike Heffron is. We're not putting an observer at the center of the Earth. When we use the globe model to test this idea, we put the observer where they're actually positioned.
Doofus, when you put the observer where he actually is, and you look at where the geocentric position of the star is, what determines?
I'm not doing that.
Shh, just listen. Just listen for a second.
When none of us do that, it's stupid. There's no reason to do it. It's an idiotic idea.
Everyone.
I don't think he understands that how the globe actually determines.
That's not how the globe does it either.
Stars are and how refraction comes out of the fact.
I got this. Doofus. The way that celestial navigation works, that the way that a GP of a star works, where it's defined as having a physical position.
We're talking about stellarium. We're specifically talking about stellarium. What stellarium does, not what celestial navigation does. It doesn't have any shit to do with what I'm talking about.
Doofus.
You're putting the person where Mike Heffron's house is, specifically for the elevation, for the pressure.
Disagree with him all you want. But listen to him.
You got to hear him out. He gets 3 words out, and you jump in. You haven't heard anything, so let him explain it to you, and then you can rebut, please.
Listen, if you're going to,
but he already said this. He's repeating it.
If you're going to, because you didn't get it at all, and you think there's a difference between what I said and what you're saying. When you use stellarium and you put an observer anywhere, inherently there's 2 positions for the star that's calculated. One is the true position of the star. That would represent where its GP should be. That's what the whole globe model is based on, where that true position is relative to that fictitious observer. When you don't have, or when you have refraction turned on, right, it's referencing where that fictitious position is, and then it's adding the amount of refraction, that they say there is, so that it shows you where the apparent position is at. So by going to Mike's house, you're doing the exact same process has already been undertaken, and you didn't see it, you didn't reference it, you haven't checked it, whatever. But it's in there. It's the same exact thing. It's just hold on. I'm not done because this is extremely important. We're about to get to the important part. Okay, so that's already inherent in it. The star isn't just at 2 degrees and 18 arc minutes relative to nothing. It's relative to its true position at 2 degrees and 3 arc minutes at Mike's house. Okay, so when you say that that's not a thing and you're not doing that, that's always done. That's inherent to the system. And that apparent position, right, that refracted position, that timing difference is the arc length added back to it. There's 27 arc. The distance between Mike's house and the mountain peak is 27 arc minutes. The drop over distance of that is half. It's 13.5 arc minutes. Okay, the amount of refraction at that time, they say, at that angle is 13 arc minutes. That is the drop over distance. That timing difference. That's a minute and a half. Or no, I'm sorry. That's a minute and 15 seconds of timing difference. So what you're saying about how we don't do this, we don't do that, I could give a fuck what you do. I know exactly what you guys do. I built a whole model based on what the globe does. What we're doing is comparing timing differences to an independent structure. If you disagree with that, I mean, I don't care. But to say that like we're doing something different or whatever, the occlusion was observed from Mike's house. No one disputes that. When we compare the occlusion at the mountain peak, that's like saying our theodolite size is the distance from Mike's house to the peak, right? Now go ahead.
You say you're using the globe to do it. You come up with a different answer than if you put stellarium directly at Mike Heffron's house and figure out where the star is from Mike's house. That means you've done something that's different than what the globe is expecting. That means when you get a different answer, you've done something different than the globe.
Yeah, or the globe prediction failed and it's adding the exact amount of drop over distance back as refraction. So
Jesus Christ.
two possible
Okay,
outcomes there.
no, that's not what's happening.
Okay.
If you put the observer at Mike Heffron's house and you get the angle to the star from Mike Heffron's house, then that's the angle you should be using. When you do this other method of, oh, I'm going to put them at the center of the Earth, then I'm going to add curvature, then I'm going to add refraction, then you get a different number. You're not using the globe. You're doing something wrong.
We're not, though. So you say we're doing something wrong, but is 13 and 13 the same number, or are those different numbers?
Because they're still talking to you.
2 degrees 17.
No. I'm just asking you if 13 and 13 are the same number, or if they're different numbers. Is the number 13 and the number 13 the same number, or are those two different numbers? Because
the prediction is 2 degrees 17 minutes. If you've got a different number, then it's wrong.
Yo, big dog, check it out. Is 13 the number the same as the number 13, or is it a different number? Go ahead.
I could say it again, I guess. 2 degrees 17 minutes is the prediction. You came up with something other than that. You got the wrong answer.
We're not even talking about the same thing right now. We're talking about a very basic
celestial theodolite. That's what we're talking about.
Nope. We're talking about is the number 13 the same as the number 13 right now? Actually, completely different. We'll get back. Get back to the celestial theodolite after we get back to that very. See, that's the fucking thing, dog. So the drop over distance is 13 arc minutes. Their astronomical refraction is 13 arc minutes. They fucking added the time back. He can't answer. It's very.
They're not going to
It's
answer.
it's so fucking simple.
They're not going to answer. And I keep telling them because they swear up and down that we are doing globe predictions. And I don't know how many equations that globers gave y'all to use for their globe predictions. And it's globers coming up with the peak locations, not flat earthers, but they insist that we're doing the globe wrong. And I think it's because they don't even understand what Ruhif is saying. Ruhif is wanting to take measurements with a theodolite to the mountain peak and to the star using just a theodolite from Mike's house and say that's the way the globe does it.
Well, that is the way the globe does it, but if you're not testing the geocentric position of it, like, see here's the thing, like, no one's ever tested it, right? The model is based on observation and time, right? So if they need more time, they're just like, oh, refraction. Now, because it's internally consistent, because what they're referencing is based off of time and just however much refraction they need to explain an observation, it's not a test of it to just simply observe the star. You can never know truly if the difference is due to astronomical refraction or not. You need to introduce some sort of independent variable to manipulate. That's where the mountain peak comes in. That elevation, based on a known distance and elevation of the star, peak relative to sea level, gives us that fixed point to reference. That's the whole point. That's how we get that timing difference. So when he won't answer, it's this 1313. Then when they add the 13 back in, and they say, well, when we do it from Mike's house and we add the 13 back in with refraction, that's the globe. Yeah, that's also the flat Earth time, as if the fucking star traversed the ground relative to the peak and got occluded, rather than relative to the observer. They don't want to acknowledge that or ever talk about it, because they failed their geocentric test, and they want to say, like, part of the reason why we're out of celestial theodolite updates is because the argument is from the globe lads is that you can't test the true position. The globe's apparent. It's an apparent globe. Like, they're all content with apparency, so that, like, it's reached its the argument has reached its maximum conclusion. Like, they don't want any tests done for the geocentric position. They're content with the globe being an apparent observation. When we try to introduce geometry to it, they're like, no, we don't want anything to do with that. We want our geometry, but we also want it to be based off of apparent angles. And that's not something that we're trying to do. That's why it's distinctly different. That's why we get two different answers. If we just reference the true position solely for everything, you wouldn't be able to tell if we reference the apparent position solely for everything, you wouldn't be able to tell the difference. It's only by comparing where their true positions are that we see, like, oops, they accidentally added the exact timing difference back as if there's no drop. Like, that's the whole point of this.
You think about that, John.
Yeah, it's almost nuts, because the whole thing is to test the geometry of the Earth, the surface of the
Dude,
Earth.
and all of a sudden they want to test apparent geometry, Ken. How crazy is that? When we're like, hey guys, we're
Yeah,
finally ready to test the geometry of the Earth using the sky, they're like, fuck that. We only do apparent geometry around here.
What do you think about that, Jonathan?
But no, shout out to the lads, dude. Ken holding it down with the. Sorry, Jonathan. Real quick, I know he just asked you a question, but Ken, I'm proud of you. You did a great job walking through that. That was great.
well, it wasn't for nothing. I learned a little bit more tonight.
No, it's great. The best way to learn is through, well, for me anyway, that I found is like arguing it to completion, and hearing it being argued to completion, because, like, you don't know what to ask or what to say, in some scenario. Like, you don't know what you don't know and stuff like that. And you don't know until you find out. When you get into an argument with someone, you're like, okay, fuck, I gotta go look that up. So yeah, it's great. It's good shit. We could all learn from it for sure. And I see my boy Charles Froman there before we get to Jonathan. If you can send Charles Froman a mic, he's a good lad. Maybe he wants to do a little promo of some of the work that he does. But yeah, Jonathan, what's good, my dude? McDougal Burger.
I just sent Charles. I just sent him the mic.
Nice.
Yeah, it's always an interesting topic. Usually when I'm listening, more depth is gone into than I can hang on to for the ride. I usually fly off the rails about a quarter of the way into it, because I think you guys were at least discussing why or why not put an observer at the center of the Earth, why or why not put him at the peak of the mountain. I'm just not following any of that rationality either way. Like, I'm still trying to wrap my mind around.
Gotcha. Well, let's start
why.
with the globe. Let's start with the globe. Have you ever looked into celestial navigation?
A little bit. I saw something in a video. I think maybe Veritasium did a video on what was her name when she crashed into the Pacific. Earhart.
Oh, okay, yeah, Amelia Earhart, I think.
Yeah, that was touched on in that video, because they used the stars to kind of tell where they were on the Pacific Ocean. So it's interesting, like, triple Venn diagram situation. You find 3 stars, and then you can triangulate where you're at roughly.
Yeah, so there's a PDF that I'll send you. It's written by a globe lad. He's into CellNav, and he writes like this. He just tells you straight what it is with no analogy, no fluff, or nothing crazy, and it makes it pretty straightforward. But when you celestial navigation is based off of a sight reduction. The sight reduction is, amongst other things, accounting for instrument error, so on and so forth. But one of the things that you're doing is that you are determining the angle of the star relative to a fictitious observer as if it were viewed from the center of Earth. So at some point in the process, you get an elevation. You have an elevation angle to the star, and based off of that elevation, you look at your refraction table and you look at how much refraction there is for that angle, and then you subtract that amount. And when you subtract that amount, that's the position that you're referencing for where you should go for what's going to determine your circle of equal altitude. It's not based off of the apparent position. Does that make sense so far?
Mostly. So you would want to subtract out the refraction using refraction tables in order to determine where the star really is if
Yep.
there were no atmosphere. So then, if you know, let me see here. If you know what time it is, I can't really articulate it well, but
Yeah. If you know time, then you know the angle, because longitude is the time a star will be at an angle, and the angle is just the elevation, so that would just be latitude. But yeah, if you know the angle, and if you know the time, and if you know your local time, and you know the star, you know what angle it's going to be at that time.
right. So then that comparing, let's see. So like if I was on the prime meridian going through England,
Yep.
I know that the star should be a certain angle from straight
Yeah.
above me on a
Yeah.
on a on
Yeah.
a yeah on a great circle going across the sky straight above me north to south. I know it's a displaced angle from that based on the time, but then if it's not at that angle, take that difference and then that's how far around the world I am.
Yes. Got it. Yes, and that's all done through the true position of it. Um, and so for every, from your zenith all the way to the horizon, at every 10 degrees of elevation difference, there's an amount of refraction. So they just subtract that out, and then they're referencing, the so-called true position. And so
Yeah,
that's
yeah.
what defines all of that. So when they get into like eclipse predictions and whatnot, they do that all based off of the geocentric position, and then because they don't know where the observer angle to it's going to be relative to that particular observer, so the refraction would be like a timing difference that they would add after the reverse process essentially. But to make the initial prediction, you start with the geocentric, like that true position, right? Always.
I'm surprised you call it true. Wouldn't you call that ground position?
So you could call it true, geocentric, or geometric position, and yes, that position is what defines the GPS.
Oh, okay. Okay, kind of synonymous. But
Yeah,
anyway,
kind of, but
well,
GP more relates it to a position on the ground versus just its true position angle in the sky. You know what I'm saying? But but
hmm,
but they do relate to the same thing.
okay. Um, so yeah, so you look at where Polaris is, and that gives you your latitude. You look at where it's at in the other dimension, that gives you your longitude, and that uh, why would you need two other stars then?
Well, you need at least one other star so that your circle of equal altitude creates two intersection points, and you'll be at one of those intersection points. And if you know your hemisphere, then you know which intersection point you're at. And if you don't know, then you would need the third.
Okay, and then that's based on whether or not I can see Polaris at all, if it's a clear night.
I mean, I guess.
If I can't see Polaris at all, then I'm in the southern hemisphere.
I suppose, or it's just shitty out or whatever. But yeah,
That's what
so
I mean. It depends on if it's a clear night sky. It's like, okay, there's no clouds in the sky. I should
yeah,
be able to see Polaris, but I can't, so I must be in the southern hemisphere.
yeah, sure.
Okay,
So
that makes sense.
just so I make sure I got this right in my head, because I listened to you talking about the fictitious observer at the center of the earth. Now, this is what I imagine. I'm standing on a location on a sphere, and I'm looking at something in the sky, that is supposed to be directly above another location on the sphere. So if I have, coming from the center of the earth, a line drawn to me, and then I have a line drawn from the center of the earth up to up through the geographic location where that
Yep.
star is zenith to,
Yep.
that is how you determine uh, uh, these these angles and these arc distances. And
Yes,
so
sir.
when somebody comes in and says, "Oh, we don't reference the center of the earth," it's inherent. It's not something that you specifically have to calculate for. It's something that's done
So
automatically.
it's already done. So it's what defines the entire model. So what Jonathan was talking about earlier with the meridian line through Greenwich is they take what's called the first cusp of Aries. So some guy 400, 500 years ago, however, or 300, 400 years ago, took a zenith measurement of a star on the spring equinox, and from that they just added 15 degrees per hour to everything, and that's what defines it. So 15 degrees per hour relative to the vernal equinox, and then position wise, where they were relative to Greenwich. So that's all. That's how the whole thing works. And so like they disagree with like, oh, we don't do that, we don't use that, but they do. They just don't. They just have never tested it, and they are only thinking in the apparent because that's all anyone has ever seen, which is also our position, right? But so we share some common ground in there. But yeah, they don't like the testing of the thing that makes the coordinate system itself, because it always ends up being, like dude was saying, you must have done something wrong. It's like, I didn't just happen to do central angle theorem, chord tangent theorem, and inscribed angle theorem haphazardly, and the fucking difference between all of our timings is the drop over distance added back as refraction. Like I did, like that didn't just, you know. So anyway, I hope that helps.
Yeah, but I would have expected Doofus to pick up on what you were saying, because if you're going to have anything relative to a sphere, you're going to have to measure from the center, no matter what.
So acknowledging the point leads to a conclusion. They never do it. That, like, what I found crazy about this whole process is like there's been times where I was wrong about stuff, or I'm like, oh yeah, you're right, and then but like never from never from them. They're never like, oh yeah, we do that, but then refract it back. Oh, that is precarious. The exact amount 13 is 13, huh? Let me think about that. Like the dude literally just left. Like, it's 13-13. He was like, nope, I'm fucking out of here. Like, anything that leads to a conclusion is a no fly zone in this, and that can happen on both sides. I've seen it. Not to just single out the globe lads, honestly. Um, 'Cause I've seen it not be, on points that aren't even like a make or break. No, it's my.
I see Shane in there. There's mics available. Oh,
The
your
I
friend
want to.
Charles is here too.
Oh, yo, what's up, Charles? Sorry, Jonathan. Didn't mean to cut you off.
No, no, go ahead.
You hear me?
Yes,
Yeah.
sir.
Um, yeah, I'm a fan. You guys, every Friday I share B Flat's tweet. Time for Globers to struggle to prove the curve motion or space without a container. Um, I'm a podcaster. I'm one of the main health freedom lobbyists, National Health Federation, and I sell sharing, make money on commission, get folks out of Obamacare. But Freedom Hub, for years, I've had people pushing the envelope, including Alan. Alan, sorry, you may recall my non flat earther co-host piling on you with his friends
Oh, it's
after
all good.
you gave a nice presentation on Nazi radar, and then they proceeded to ask you irrelevant questions, basic flat Earth 101 kind of questions. You were getting kind of frustrated, going, "I'm sorry, did anyone pay attention to my presentation?" So you were a good sport, but it was kind of laughable. Surprised you talked to me after that.
No,
But
it's all good, bro. That guy is hilarious. He goes, yeah, but how do you reconcile the fact that my friend who has top secret clearance at space agency told me that there's a secret mission on the moon or whatever? Some dude, it was the most ridiculous. He's like, how do you fix that one, guy? I'm like, I don't, man. You win.
yeah, that's
Oh,
Jim.
fuck, I've never heard of hearsay before. Oh no.
Yeah, he always brings it the same rebuttals. It's like a friend. Here's a video saying you're part of the psyop, and then yeah, his friends and the secret ops that he claims to have. We're both in the health business, but once you accept the reality of this earth, not everyone is ready to hear that truth, and so you have to decide whether to stay with them or move on or just be cagey about it. But like most podcasts, I had Dave Weiss on, Mark Sargent, and then you asked Dave who else to bring on, and Matt Long. I had Brian's friend Dustin Emos on a couple of times. Um, I had Jaron on right before
Oh,
TFE.
oh nice.
I am. In fact, his appearance with us was a month before,
Oh
and he
wow.
gave it. He gave, as we all know, a fantastic slam on the globe,
Dude,
going through
always
all
does.
the
Always
rocket
does.
launches. So it's sad what happened with him. But Dave Weiss was just on again talking not about FE but about his Tesla coil. I think he enjoyed being able to discuss something not focused on FE. It was a Tesla coil. We showed the toroidal shape of our plane, and it was good. And if folks want to go to my Substack at charlesdfroman.substack, I think that's it. You'll see an article I wrote about FE. I kind of looked for all of the more well-known podcasts on which this topic was platformed. It's pretty impressive. If you look at all the lists, from Roseanne Barr and Glenn Beck's program. So there's a lot of progress being made. So, and you guys every Friday, this is fantastic. Thanks.
Yeah. No worries. Do you have something coming up? I thought you had something else coming up in September or something with Kyle or something. You have anything coming up?
Um, Coming up on what was the question? You faded or I faded?
Oh, I thought you had an interview coming up with Kyle from Glowbusters.
No, he's one of the. He never got back to me, but I would love to have his. He did. Did a new science book, right?
Yeah, I'll send him an email again.
For school, for homeschool.
Yeah, I think he may be
Yeah.
technologically.
So I'm always trying to get. Okay, yeah. So anyone, I'm looking for new content, people hear issues in stereo. So you never know who is going to convince somebody. So you want to have new people on all the time on the same issue. So yeah, I'm looking
That's
for new people on this issue. As far as me speaking, I'm a speaker at a lot of health freedom conferences. I'm the lead lobbyist against the wireless mesh. So I'm the guy trying to keep these cell towers far from your bedrooms, kids' classrooms, and local parks. It's not going very well. Telecom's a pretty powerful industry, but we have, the frustrating Zoom meetings with congressional staffers the other week on the truth about our risk. It's not easy to get vaccines. The pandemic helped us because now people are thinking, but we're not making much progress on the cell test because people just convenience. They don't know what the dangers, but it's severe. And so I know all the people and all the health freedom issues around RFK's world, geoengineering, etc. But I really just enjoy you guys. This is changing people's lives, knowing that we're special in God's creation and we have a purpose. So thank you guys.
thank you. I will. I'll reach out to Kyle and get back to you on that and see if we can work something out because that dude's lacking on the email department there.
Yeah, if he has a new homeschooling science book, that would be something people want to find out about. We do a lot of homeschooling
Absolutely.
stuff,
I know he would
a
love
lot
to.
of libertarian stuff.
So I don't know what the holdup is here, but we'll get it sorted. What's up, Shane G? I see you out there in
Well,
the streets.
What up, fellas?
What's
Alan, why is your
Shane?
mic shit? Why is your audio chaos shit? Why does it fluctuate between shit and then super close, super loud stuff like you're actually paying attention?
Because I'm on my phone,
He's on his phone.
and then also I see Simpu down there. Shout out to the young homie. And then there's also Mr. Zave, who I've been waiting for all day. Zave, I'm gonna need you to grab a microphone, brother dog. We got a telescope full of water and a star to discuss real quick, my dude.
See, now you're super loud, and I feel like
I
I've
sent him a
ruined
mic invite, Mr. Xavier.
Yeah, come on up,
You can
man. Come on up. Before we get onto that stuff, we do have a new speaker in here with 7 followers, so I gotta see what's up. What's up there, NoTanks? How you doing?
Oh no, I'm from Discord.
Pardon?
Is that our no thanks?
I'm pretty. I don't know any other no tanks. What's up, lad?
Is this someone
We'll
you
have to
know?
hear him to verify. Let's see.
Neither one of you guys are following him.
We didn't know he was on Twitter. If it's the no tanks that we think it is.
Hey, what's up? What's up, guys? How you doing?
Yeah,
Yes, it's the one and only.
Is it the one and
nice.
only? Right on.
All right, now I'm following you. Did you join Twitter just to come hang out with us, dude?
That's a big part of the reason. That is true.
Nice.
Respect.
Come hang out with the cool kids.
I've been social shaming people at the end of my streams. I say if you're not following Ken and Brian on Twitter and participating in the Friday space, you're probably not very cool.
Yeah, I agree.
Putting a little pressure on them, a little pressure.
Yeah, it's an aggressive form of self promotion that I've been agreeing with. I think it works well.
Dude, imagine not being viewed as cool by peers. Isn't that frightening, guys? Are you guys terrible?
Imagine not being able to socially shame a group of independent critical thinkers.
And when we do it to one another, we take a lot of pride in it.
So hard, dude.
Oh, hilarious, dude.
Well, welcome, man. Welcome to X. Every now and then we get it. Well, we got Jonathan in here. He's in like some kind of denial phase.
I heard him just acquiesce to the celestial theodolite a second ago when he was asking pertinent questions with zero follow up and accepting Alan's explanations or whatever.
Dude, I actually heard Jonathan arguing it in another space as a flat earther. It was crazy.
Yeah, dude, I imagine it gets sickening to hear the nonsense put forward by their side when he knows that it's just pure retarded. He's like, come on, that's not even, guys, like, that's not what the, really? Like, respect, dude. If that's what you're doing, respect.
I mean, that's about the only thing that you can do is at least understand it. You can't really refute it if you don't understand it. It's the whole point of trying to steelman something.
Yeah, and you only saw when the Globers understood it when you watched the whole progression play out over the year that we were presenting it. When they changed their position from like, oh, this is great, and I go to, oh, it doesn't work at all, to, oh, it definitely doesn't work. You know, like, to be like, oh, there was a progression of acceptance when they went through the process of acceptance, grief, bargaining, and they were like, you know what, abject denial. We're just gonna go with it doesn't work.
Dude, no. Not only does it not work, but it only works on Pikes Peak. It works perfectly on Pikes Peak, but then everywhere else it doesn't work somehow. Like it's like shit like that. They would say. They're like, listen, if I do a separate analysis, like if I do your analysis on Pikes Peak, yeah, sure, fine, it works. But if I do a separate analysis on every other peak, it doesn't work.
Dude, one
You
of the
know,
funniest ones that I heard was when you debated with Astronomy Live, and he was all like, you owe me $200 for these readings. And you're like, bro, if you can repeat it, I'll give you $400. And he goes, how can I repeat it?
That's the
Like, who cares about geometric intersections? Who cares? Not the globe. We live on an apparent globe, or whatever. Another good one.
Yeah, that was the highlight of the whole thing.
Dude, what the celestial theodolite process told me was that none of the globers we argue with have any capacity to handle independent arguments. Like they want to talk about how you think satellites are on balloons or that the Earth isn't flat because you don't understand refraction. And if it goes beyond that, they're not like interested, right? Like they don't want to learn. And there's no dogma for them to like reference. When you throw celestial theodolite, they can't Google it and be like, "What's the globe answer for this, stupid flirts?" Wait a second. Okay, what am I supposed to say? Like how they do for all their basic like flat earth.ws meme response level stuff to all the things. So like when you throw stuff that isn't in the dogma, doesn't have a set like a classically agreed upon answer, they all flounder and have no idea. They all made up different answers to the celestial theodolite. They had conflicting, differing answers in math and opinions until they finally got the shit together and decided that it was all nonsense or whatever. Like it was crazy.
Dude, until they all got together and decided that they didn't like it.
Yeah, and then John.
You know what we also did? We all got together and decided that we didn't like the globe, and so like, are we allowed to just do that now? Are we just consensus based fucking people now?
So then, who's gonna throw the next cleverly crafted, well-sourced, independent argument at him to see them flounder for a year? We should do one every year, like a minute rotation.
Dude, it was 42 weeks, dog.
Yeah, no, I was definitely like, so my soul was drained by the 20th week, and I wasn't even doing most of the work.
Dude, I ain't gonna lie, man. Listening to some of these arguments, I snapped one week, and I was like, "Damn, I did go off, didn't I?"
Dude, I know. I heard you, and I laughed, and I was thanking you internally. And after that, I was a little bit more of an asshole to it. So I think you might have inspired me to be more of a dick.
If I can inspire you to be more of a dick, then I know I did something.
Well, I've been drifting as Alan drifts nicer. I've been drifting meaner. I don't know what the answer for that divergence is over time, but it's been a pattern I've noticed. Like I used to be way nicer to these people, and now I'm like, it's way different. I don't know what happened.
Just continuous non-conclusions over and over again has made you.
Yeah, that is what it is. Like your absolute refusal to conclude a single goddamn argument or conclude anything is so frustrating. It's like I don't care. I don't care at all about what you say about anything.
Yeah,
that's where I'm at.
And once you get to that point, it's hard to get back from it. I'm trying to get.
It really is.
It really is.
Enjoy the debate, enjoy the conversation, but I'm just like, you don't give a fuck about what I'm saying, so why why am I reciprocating?
It's like you can't even entertain a hypothetical in your head. Like, what would it be like if you didn't have breakfast? But I did have breakfast all day, every day. That's all it is. It's like, what? No, I'm asking you. Like, all right, we make allowances and arguments. Like, let's grant curvature or something. Let's assume that we live on a sphere. Where's the motion or whatever? They can't even do that. They're like, but it isn't. It's a globe. It's like, okay, you guys are great.
Dude, that's one of my favorite questions to ask people. How would you feel if you didn't have breakfast? But I did have breakfast.
but I did have, but I had breakfast. They'll tell you like what they had. It's like, oh, you didn't get the point of the exercise at all.
Speaking of
I remember.
exercise.
I was going to say, I remember somebody mentioning telescopes and water and.
Yeah, I was just about to say. Speaking of exercise, anyone try to lift a zenith mount filled with water? Yo, what's up, Zave?
Yes, what's up? Sorry about that. I had to finish making this sandwich.
Did you get a chance to watch McToon's video on the Airy thing?
I did. And
brother, it's dude, it's gonna be so good. So, I started looking, before I, speak on something. I always like to double check and find more references, so on and so forth. Oh boy, what did I found is, dude. Okay, so get this, guys, get this. What they've been doing to us by presenting the the 20 arc seconds in water, guys. That's the geocentric prediction. That's not even the Earth moving prediction. There's a different prediction for water moving even in relativity theory. Now, I bet you're wondering, but Alan, I've never seen anyone show the moving frame. I just assumed that because they think the Earth is moving and they analyzed it in the geocentric frame, that somehow implied that, the Earth was moving and it could produce the 20 arc seconds no problem. Well, that's where the trick doth begin. They've actually never shown it in any academic texts, no published papers, nothing. It's alluded to, right? But no one actually shows what the moving Earth predicts around the sun. Well, that's weird. You'd think they would show that because they're super into transformations and reciprocity for the transformation. Okay, so check this out, Zave. Telescope in water on a moving Earth. Like let's do what Shane said. Let's do a hypothetical, even though we ate breakfast or whatever. We've got the Earth moving around the sun. We got a telescope in air. For some reason, the star appears to be 20 arc seconds deviated from where it should be. Okay, so we're like, oh, this must mean we're going around the sun. Then we get our telescope, we fill it with water, and we get the same exact angle. Now, what do we do mathematically? Because we know that when we add the water plus with our velocity, the angle should increase from 20 arc seconds to 27 arc seconds. Okay, this has been mathematically proven. That's Snell's law. Fizeau and Michelson did experiments in the 1800s using rotating mirrors and tubes of water. Velocity plus water slowing water slowing light equals a larger angle. It's a fact, right? It's an experimental fact. It actually falsified the previous theory of light propagation, which was that light propagates as little ballistic BBs, little corpuscular bullets, which was called emission theory. And so the math prediction for what they predicted when the light entered the water was that it would accelerate. So they multiplied by the refractive index rather than dividing. And that gives them a smaller angle. So they predict a smaller angle. So if the light accelerated, the angle would be smaller, but the angle increased. So when they put the water in the telescope, they all knew the angle should increase. Didn't increase. So they had to come up with explanations as to why it didn't increase. One of the explanations was, at the time, because they all believed in a cosmological ether that was at rest that the Earth moved through, they simply said, and this is ad hoc, that the ether inside of the telescope is bouncing around and it's carrying the light in the opposite direction of motion such that it cancels it out exactly. And they started to believe in this this non-ability to make a measurement of Earth's velocity through space based off of that. They just started interpreting their null results as, oh, this must be because the ether is blocking it for some mysterious mechanism. And so every time they would measure a null throughout the 1800s, they would go, "Oh my God, we proved the Earth's moving again because the ether's blocking the first order measurement." And so with that, there's let's see. See. Okay, so there was another theory. This is when they started getting more into the math for transformations. This is where they apply Lorentz's theory. So Lorentz also had an ether theory, and his wasn't based on the Fresnel drag to move it in the opposite direction type thing. His was the mathematical transformation, where you treat something as stationary and analyze the moving analyze the moving frame from the stationary frame that you artificially create, mathematically. And so when they talk about 20 arc seconds in air, I'm sorry, when they talk about 20 arc seconds in water for a moving Earth, that's actually the geocentric prediction for the stationary frame. That's what it would be geocentric wise. If the Earth is moving relative to the sun, what the prediction becomes is 13 arc minutes. Now, I bet you guys are wondering, wait a minute, Alan, didn't you say that emission theory was falsified? How could the angle be smaller in the moving frame? And if you assume that the Earth is moving and you measured it at 20, and you didn't measure the moving angle that you predicted, how can you use the geocentric prediction as proof that the Earth is moving? Because you should have measured 13 arc minutes. Because here's the thing, check this out. And this is what Franco showed in his PDF so elegantly, was the internal angle of the light as it's in the telescope. So when you add refraction with C over N, you get you have C propagating at 0.75 C, so it slows down. So the internal angle of the light is 15 arc seconds. If you multiply the refractive index, Lorentz also had an ether theory, and his wasn't based on the Fresnel drag to move it in the opposite direction type thing. His was the mathematical transformation, where you treat something as stationary and analyze the moving analyze the moving frame from the stationary frame that you artificially create, mathematically. And so when they talk about 20 arc seconds in air, I'm sorry, when they talk about 20 arc seconds in water for a moving Earth, that's actually the geocentric prediction for the stationary frame. That's what it would be geocentric wise. If the Earth is moving relative to the sun, what the prediction becomes is 13 arc minutes. Now, I bet you guys are wondering, wait a minute, Alan, didn't you say that emission theory was falsified? How could the angle be smaller in the moving frame? And if you assume that the Earth is moving and you measured it at 20 and you didn't measure the moving angle that you predicted, how can you use the geocentric prediction as proof that the Earth is moving? Because you should have measured 13 arc minutes. Because here's the thing, check this out. And this is what Franco showed in his PDF so elegantly, was the internal angle of the light as it's in the telescope. So when you add refraction with C over N, you get you have C propagating at 0.75 C, so it slows down. So the internal angle of the light is 15 arc seconds. If you multiply the refractive index of water, which is 1.33, if you multiply 1.33 by 15 arc seconds, you get 20 arc seconds. Okay, that's totally valid. That's fine. That makes sense. Now, when you do the same thing to the moving frame, right? When the Earth is moving now, because the V over C, because the initial angle of aberration is created by the velocity component, the V over C, to get it. When they when they go to transform from stationary to the moving, they actually divide the refractive index one more time. And that's how they end up getting a smaller number in the moving frame. And if you multiply the refractive index of 1.33 times 13 arc seconds, you get 16 arc seconds. So if the Earth were truly moving through space, and if relativity were true, there's no preferred frame, yada yada, then when he put water in the telescope, he should have measured 16 arc minutes, and the geocentric transformation to a stationary frame would give the 20 arc seconds, but that would be like a mathematical artifact of the frame, and it would show that the geocentric frame isn't a valid frame. But it's the fucking opposite, boys. They measured 20 in the lab. When you transform to the moving frame, already assuming the velocity component in it, you get a smaller angle. That's why they never talk about it. That's why they never show it. That's why it's always presented in the frame as if the Earth is at rest. But the Earth isn't dynamically at rest if their model is true. They could treat it as rest, but that would end up showing the exact mathematical difference that I just talked about, 16 versus 20. But it would be reversed. We would measure 20 or 16 in the lab, and 20 would be the fictitious number. So they're totally fucking cooked, bro. And then so I found these some citations of them talking about this. And so Wolfgang Pauli, who's a high-ranking relativist, very authoritative person on the subject matter. He derived when he was like 16 the aberration angle in water, the same situation that Franco did, but then said that if you were to try to do the analysis in the moving frame, it gets very complex and it's hard to explain. And what's hard to explain about it is that you have to have the light fucking accelerate in the telescope to match what's measured in the lab. It doesn't make any sense. Like it's not difficult to explain. It's impossible. It's physically antithetical to everything that's measured in the lab. So that's like the real issue. So no one's ever actually shown it. So big shout out to Franco for providing that and deriving it from first principles and going all the way through it, because what he showed exactly is the hidden thing that's never been seen. And when we look at it through, oh well, the angle remained 20, it's 20 in air, therefore we're moving. No, 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 no. Nope. Because if you do the same refractive index multiplication, you need to get what's measured in the lab frame, and you only do that when the angle is 15. When you've already, in that regard, that's the geocentric angle where the Earth moves. I mean, where the Earth is stationary and the sky moves. So yeah, it's oh, dude, it's so awesome. So there's going to be like I said, I'm working on a video for that, but I just got everything rounded off, just got all the math and stuff sorted out, so should be coming on that soon. But I was excited to tell you because you asked last week about their position, and I gave you the explanation, but I didn't fully like. I didn't give you the full grasp of like what that internal angle is in the moving frame and the relationship of multiplying the refractive index back. Because if it doesn't give the angle that's measured in the lab, then it means fuck all. It means absolutely nothing. Like imagine if we were like, yo, we have a prediction, and they're like, okay, and then they were like, well, your number's off, and we were like, yeah, but we don't care. The number's there. Like that, that would we would get laughed out. It'd be ridiculous. That wouldn't be a tenable position. That's absurd, and that is their position. There is no way to do that. And then so check this out. Another interesting thing, because of the way that it makes the angle smaller relative to the velocity as a function of the refractive index misuse, in the same way that emission theory ended up with a smaller angle, they also predict, that smaller angle, which is fucking hilarious. So there's not even a different prediction. No theory on Earth predicts 20 arc seconds except for a stationary Earth.
Hilarious, but totally expected.
I sense a Prezi coming up.
You know, it's funny. When we talked about it, I said, "No way, Alan's got to be mistaken about jumping to the sun's reference frame." So I said, "Let me do my due diligence and give the devil its due and listen to a presentation." They brought him a quant. Yeah, we're good.
Still terrible.
Yeah, it's clipping a lot. But just to finish up, I got the there was a physicist that McToon brought as a backup to explain Franco's paper because they were sure you messed it up, and I was expecting to write a lot of stuff down to review. Long story short, after a 2-hour presentation, this was the end result. Just listen up; it'll take less than 30 seconds.
Nice.
I don't know where he gets some of these numbers from. And I want to say I'm sorry if this kind of fizzled out. I didn't mean that, but I was under the impression that you would, like I said this a couple times, that you would have more context that we would be able to.
Yo, that's so funny.
We need to go deeper and go back to start at the beginning with Franco.
Yeah. So.
Yeah, Zave. There was a part in there where he was like, the look on his face when he says it, he was like, Franco gets 15 in the moving frame. It's supposed to be 20 though. And then the look on his face, bro. And then he's just like, that is like your conclusion was our premise, dog. Like he has no idea that the context is that our premise was that no theory explains the measurement. And you have to, in the moving frame, you have to have the light accelerate, which makes no sense. And everyone's like, no, we don't. And then Franco made that document for us. And at the end of the paper, he's like, by the way, if you try to solve for the speed of light using the moving frame, it won't be C over N. What? That's our fucking position, dude. So, yeah, dude, it's been great. It's been great. I've learned so much. I can't. I look forward to sharing it with everyone,
Yeah,
with
if you don't
diagrams
mind
and
me,
stuff. So,
if you don't mind me
yeah,
being a fly on the wall when you get to do that presentation on Discord, I'd love to do that if you can.
yeah. Well, it's coming soon. It's
Dude,
gonna
I
be.
can't wait for the first Glober to be like, haha, you didn't see when your stupid area position got refuted by McToon and a PhD? Haha, you're an idiot. I watched it. Here's the link.
It's like and then they link a video of them both agreeing with my position.
No idea what the even argument is. Like, they have
Dude,
no idea. Even
dude,
the
it's
capacity to
wild.
determine who's on what
Then,
side. Yeah.
dude, if you look at the comments on the video too, they're just like, "Oh, dude, you guys are so right. Lamau flat earthers are so dumb." Like, bro, you guys have no idea what's even about to happen.
The strange thing is, instead of just acknowledging the L, hey, listen, maybe we need some more information, he just started going on a tangent about particle wave duality and how that relates to quantum optics. It's like, what are we talking about right now? Can we focus?
Yeah, absolutely nothing. And it's like, uh, you know, he was probably just trying to bring it back to something related to his field. Honestly, I don't even blame that guy. He probably just got drug into it because like obviously McToon's never looked into it and he thought this was going to be a slam dunk. So
Dude, that response said it all. He's like, I thought you would have more, honestly, Michael, when you talked to me privately. Like, that's pretty much what he said. And it was like, all right, if McToon had read the paper in the first place that he said he didn't read, that he published on his website, he also wouldn't have been as confused. So,
yeah,
read the paper, bro.
hilarious, dude.
And then he started trying to bring Piezo, but well, he needed to walk it down and give me every single detail. I need more context. Like, what the?
And you know what? Piezo did give him the math and stuff for that when he asked for it, and then he just acted like he didn't send him the message on stream.
Right, he played the interaction in the beginning of his 2-hour
Yeah,
presentation.
yeah, he showed everything except for what Piezo actually said when he gave him the math when he asked for it. How fucking like, dude, this whole like you gotta lie to flirt, like, dude, man, if you guys fucking applied a critical eye to what that dude does, like, get fucked.
Yeah, it's pure projection. The first law of Glurf, we should call it. You know, his proof is our premise, and thanks, I guess.
Yeah.
You know what I mean?
That should definitely be a rule of being a flat earther is your conclusion is my premise. My premise is your conclusion every time, all the time.
So I gotta look through the math because I'm looking at it and I'm looking at Franco's fix, and I'm looking at the B times n minus 1 over n. I gotta like parse that out and see how. I know it's BS, but I gotta see what he's at least attempting to do.
Yeah, so the beta includes the V over C relationship already, and then he's doing the refractive index one more time, and that's what makes it smaller in the sun's moving frame because it's already the refractive index was already accounted for the first time, so it's like a double dipping thing
Yeah, I noticed
that
that. I'm wondering
ends up
what's the
messing.
justification for doing that aside from we need to make it work.
There ain't one, brother. That's why they never show it. It can't be like, dude. He did the unspeakable. He spoke Voldemort's name or whatever. He showed us because like dude, I was working on this and I was like getting really frustrated because I was like, well, wait, what about doesn't the sun like how does this work in this? Because the way that he presented it is from the sun's position instead of doing it from the Earth. So sun stationary and sun moving, he does the analysis in, and then obviously the measurement was done on Earth. So you would I was like trying to wrap my head around stationary Earth, moving Earth, and I'm like, but we measured 20 in the lab, and then it hit me, and I'm like, oh fuck, they don't show the moving frame because of this. Like, this is why they don't actually show it, because in the Earth frame, that's what it is. It's not just the sun frame, because that's just transformation for what the observed angle is. So it'd have to be the same because we either go 30 kilometers around it or it goes 30 kilometers around us. So it has to be the same. But so yeah, once I realized that they predict 16 in the lab frame, I was like, oh, it's on, dude.
You know what threw me off? As much as McToon has been involved in these conversations, he didn't even know 30 kilometers per second was the predicted velocity of Earth. I'm like, what have you been doing all this time?
Unlucky, dude.
Dude, he's been not listening, not caring, and just confidently saying to everyone else how stupid we are about everything. That's been the whole position. It's what his channel's built on. It's what he's done since the beginning. Makes no difference what we say as long as he keeps doing that and saying confidently. When he debated Alan on relativity, he was sweating so hard he forgot to do that, and all his audience was confused. And it was like, what? Like, well, why is he not smiling confidently and cockily? I don't understand. So like they felt like it was off and it was weird, and he had to do like a recoup after that. But that's pretty much all he has to do is just sit there and confidently tell everyone how wrong and dumb we are, and then everyone will just eat it up. That's all the Globers really want to hear, dude.
Yep, well said. Enough about that dude. Stone G, what's good, brother?
Gang, how we doing? Finally got here. Sorry I'm late. You know, shit happens. What was this thing about, Tim? What just happened? I missed that entirely. Want to recap me there real quick?
Yeah, so you know how we've been saying that the Earth is stationary and you can't measure 20 arc seconds in water in a fucking telescope if the Earth's moving? So Toon finally did a review of Ares' failure based on his interactions with Piezo the last couple of times. And then so he reviewed it, and we gave him Franco's document on how he derived the relativistic answer for aberration. And they went over it, and then it gives a answer that doesn't agree with what it should be, and then they were like, well, we don't know what to do from here, and then they just kind of talked about other stuff or whatever. So there's going to be an upcoming Aries video, going over all this. And now that I better understand the math relationships for everything, it's like it's going to be great.
So they finally figured out that Einstein doesn't agree with Galilean Dopplerian analysis. What else? What else is there to embrace there?
No, that would reach a conclusion.
Yeah, they're not, but they came hella close to it. It was so funny. He was like, "It's supposed to be 20, though." Oh well.
That's hilarious.
Yeah, so we were just talking about that for a minute.
Talk about slow on the pickup. Holy moly.
I mean, after 13 years, getting someone to finally look into it, I'll take that W.
That's tragic.
What do you think you'd have to do to get him to read the paper with that he won't publish?
Next time he goes live, I'll donate him $5 and be like, I'll give you $5 if you read this or whatever.
Oh, I don't think that'll be worth it.
It would be, because the fucking opening abstract of it is hilarious. This dude's like Cliggerfuse was like, guys, if the Earth's dynamically moving, obviously there's going to be consequences. Like, even if there's no ether, there still has to be an angle change.
Yeah, it's like, wait, what? It's for 3 years. That's so funny.
It's like, I just haven't read it yet. Okay.
Why do you think he has the need to say separately 3 times that he hasn't read it? Just to broadly proclaim that he doesn't agree with the preface?
I think because he at least started to read the abstract and was like, oh, well, this isn't good. Because like the argument that I've been making the whole time, and I'm just a dumb fucking whatever. But it's like, it's this dude's starting premise as an experimental physicist.
So unimpressed.
I think if it didn't come from Franco himself, he would have dismissed it.
Yeah, I'm so glad it did, because like I said, you can't even find anyone that's ever shown the moving frame. It's literally only ever talked about in the rest frame of Earth.
I'm telling you, Franco is useful. He knows his religion inside and out. You just got to get him talking.
Well, he knows when not to talk too. He's like, "Oh, I've seen ventured into dangerous territory where I may decredit myself, so I will refrain from speaking."
Yeah.
Like, okay, that's a pretty smart way to do it, I guess.
He pleaded the physics fifth.
Yeah, I was just thinking that was too easy. It was a layup.
Was it Michael Brenner says reality doesn't care what reference frame you choose? We live in a real reality, man, not a coordinate system.
No, that was Lawrence Fishburne.
Denzel Washington, maybe. I think I heard him say that in The Matrix.
So Xavier, you asked a while ago what was the justification for double dipping. I put my Glober hat on. I think I have an answer.
Go for it, brother.
So the justification for double dipping is because it gets you closer to what you need.
Well, the justification for the double dip is that if they didn't, then they couldn't have the geocentric frame as the rest point matching what was measured in the lab. So yeah, it has to be that. And then so when Michelson opened up his paper in 1887 for the Michelson-Morley experiment, when he's like, guys, the Airy failure situation's crazy. The emission theory has to predict it goes in the opposite direction and accelerates. It's retarded. It goes in the opposite direction. Or I'm sorry, emission theory predicts that the light accelerates in the water, and the wave theory predicts that it has to be carried in the opposite direction. So that's where we're at. It's never changed. If the angle's smaller, guess what, boys? That light just accelerated in the fucking water, which makes no sense.
Well, that's a problem for emission, anyways, isn't it?
Yes. So,
it slows down in light or in water.
Yes, and here's the thing.
So when it exits, it has to accelerate again, right?
No, so it's worse. They're saying that it accelerates in the water. We're saying it hits the water and goes superluminal. It goes, instead of dividing by c and going 0.75 of c, it goes 1.33 times the speed of light.
Damn.
Yeah, it's insane.
Because it's a denser medium?
Yes, and they thought that they had to multiply by the refractive index instead of dividing by it, and that's what Michelson and Foucault experimentally falsified.
Well, isn't it intuitively natural you would deduce that? I mean, you're talking about energy propagation through mass, not actual. I mean, that's acoustic theory. That's compaction, rarefaction. Rarefaction. You know what I mean? That's
dude. They had to go through it, bro. They had to be sure.
I guess. I mean, it's scientific. Rule it out.
Yeah,
as banal as it may seem.
Hey, Jonathan, are you familiar with Airy's failure?
Yeah, only the rest makes the correct prediction.
I am not very familiar. I mean, I've heard of it and I've heard you guys talk about it, but I still don't fully understand it. I just posted something in the Blue Pill sketch I made. That's how I picture the celestial theodolite problem. And I guess the main thing is picking a mountain that's far enough away so that the two ranges of possible data points are mutually exclusive. In this case, I'm showing the one where they're not. So, but that's because I exaggerated the effect of refraction in both cases. Anyway, I was just having fun with it. Wanted to show you guys.
I'll put it up in the nest for you.
Okay. So yeah, obviously refraction isn't that severe, but I did find out that, and Alan, I wanted to share this with you. I did find out that there is a way to independently check what the refractive index of air is, and that is by splitting a beam, letting one hit a mirror inside of a near vacuum chamber, and letting the other one hit a mirror without vacuum, and then recombining them and seeing the fringe pattern. And supposedly that's a very accurate way to tell how much slower the light, how much longer the light took to come back. So both beams of light can be pictured as waves, a wave front. And so if one wave front is delayed and it comes back after bouncing off the mirror, then it will not recombine perfectly and it'll create that fringe pattern. So you can deduce exactly how much longer it took, and hence, by definition, what the refractive index of air itself is. So with that, you can use the ray equation derived from the iconal equation, and it's first principle stuff, and then you get into its differential equation form, and then you use a differential equation solver, just a generic solver, write some code, and then boom, you have a ray tracer for beams of light through a gradient, and you can test it for a flat Earth, you can test it for a globe Earth. But the point is I want to do that and figure out what those curved paths really look like in real life for both flat Earth and round Earth cases. And this is just a sketch of kind of where I'm going. So this is the reason why when I hear, we're putting an observer in the middle of the Earth, we're putting an observer on the mountaintop, my brain doesn't even go in that direction at all. All I'm doing is running with this whole celestial theodolite idea and relying on line of sight without atmosphere, and then curved rays with a atmosphere, seeing how far away does it have to be for these two data sets to really diverge, and then going from there.
We got you.
Have to spherically integrate that measured refractive index over a sphere to make concentric shells to satisfy Snell invariant. So that's not going to tell you anything unique about whether or not it's actually doing that or not. And that's why when we compare the timing differences from the observer location to the peak, the amount of timing difference, right, is the drop over distance. That's why the refraction amount is the same as the drop over distance amount, because it's been spherically integrated already in the model. So it's literally compensating for it. So just ray tracing it alone isn't really going to tell you anything unique. And we don't believe in that refraction gradient that you got that is invoked as the globular explanation. We believe it's more of an optical mechanism, as a facet of them moving away from us, and then our vision being curved, and having as things get closer to the horizon and further away and they're higher up, etc., they linger, they appear to be in the same position rather than continuing to go down and stuff. We don't think that that's necessarily a facet of, a shell of atmospheric, so on and so forth. So you would need to account for a different mechanism, because there's no way you can make the curved gradient like that on a flat Earth to integrate over a sphere if the flat Earth doesn't have a radius. So it's not going to integrate. It's not going. That's not our mechanism for it. We think it's purely optical, or mostly optical. Like, I'm not saying that there's not refraction and whatnot, but to the amount that's invoked that's spherically integrated, like, that's not telling us anything unique at all.
Okay, and again, I'm kind of hanging on for dear life as I'm trying to listen to the terminology you're using and relate it in my own head. But so I'd have to kind of go back a little bit. I apologize, but I want to start from a place where we both kind of have the same terminology, I guess. And that is, you mentioned, for example, spherical integration. What do you mean by that? What do you?
So one of the starting components, like all those papers that I sent you a while ago, all those papers take that interferometric measured amount for the refractive index of air at mean sea level, and they integrate it over that radius. They construct a model of spherical shells that go radially outward, 80 kilometers above the surface of Earth, starting from the center point.
I actually tried this using Snell's law. I wonder if we're talking about the same thing here, but I used the concentric shells, like you're mentioning, of increasingly thin air as you go up. And I simply used Snell's law and varying increments. I could control the increments. This is basic, Euler's method. And it actually broke down as it approached horizontal to the local ground, and it was giving me these bogus results. And so that's when I remembered, oh yeah, you guys are the ones that warned me that was going to happen. And so I had to find out, for myself. Anyway,
no worries. The best way to do it is to go through it and do it yourself, I've found. So
well, you can appreciate it, and I did find a source where somebody reiterated that, and it says, no, you have to use the Ray equation. And the Ray equation is derived again from this idea of path of least action or path of least time, and which is an amazing equation. It explains so many different. There's a great Veritasium video on it. It just explains so many different, varying, seemingly unrelated facets of physics, and you can figure them all out using the same starting point. This principle of path of anyway. So it's
a Euler Lagrange or a Hamiltonian. Is that what you're talking about?
Yeah, Euler Lagrange. Yeah, exactly. It's a method. It's a method that's related to path of least action. So this is derived from that same principle. And what I think is beautiful about it is if you picture a wave front that is traveling horizontal to the ground, and there is a gradient of air that gets thinner as you go up, you can imagine that. Oh, and here's another cool thing. A wavefront can be modeled as infinitely tiny little wavelets that are wave sources that are fanning out in all directions, and then they coalesce to form that wavefront. And so in that same way, if I break this wavefront down into a bunch of little wavelets that are starting a wave themselves, the one that's further down is going to travel slower because it's in denser medium. The one above is going to travel faster. Well, what does that mean? That means that if you add all these wave fronts together, it'll form a wave front that's now angling. It's now angling. Let's picture it moving from left to right. This wave front is no longer vertical. It's starting to angle clockwise, and it's going to go towards the ground. So this is something that blew my mind. I was like, wait a minute. I thought that a ray of light, if it was going through let's say a shell of air that had the same density horizontal to the ground, it shouldn't bend because it's not experiencing those little, changes in density, but it actually does. And that was cool. And so what I really want to do is dig into that and just say, okay, I'm going to understand the mathematics behind this. This is first principle stuff. And I think, we would enjoy discussing this, but go ahead and build, from code. I want to build my own code so that way I know nobody else has tampered with it. Nobody else has snuck in some kind of, tweak here and there and to compensate or whatever. It's just first principles in code form, and I can actually trace a ray of whatever angle I want. And so, and it would be based on a refractive index that is testable in a lab, meaning you don't have to use circular reasoning based on how high a star is off the horizon, which we discussed before. You can independently test that, and then you can use the ideal gas law to deduce based on known data for how dense air is above the ground. This is just known data and temperature. The standard atmosphere. You apply the ideal gas law to that, and you can. I think you agree. You can have a very reliable and true data set of what the standard refractive index is at different altitudes. So then we're good. We can actually get a very close approximation of how light would curve up to that mountain peak and beyond, out into almost near vacuum. And so
you can't do that without a radius value. I linked in the jumbo there the source code for RuHIF and for Astronomy Live's ray tracing that they did over the same thing, and it includes the radius for the spherical integration to make it fit. So I look forward to seeing your project.
Yeah, it'll be fun to do, and even if you don't agree with it, I mean, I'm gonna enjoy it, because I do like to I try to not refer to anyone, whether they're famous or not, or whether they're historic. I don't know. I don't like deferring to anyone else's thoughts or anyone else's. I want to understand it for myself.
Yeah, well, it's not that I don't necessarily agree with you, but also one of the variables in there, if you try to derive it from ideal gas law, we would be looking at having to know the air mass. So it gets into this weird thing where it's just like whatever number it has to be is what the air mass happens to be. And actually,
Did we lose him?
I think we lost him.
Can you hear
It's
me?
not me. Yay! Thanks, Elon.
Can you hear me?
We can still hear you, Jonathan.
Oh, that was weird. Oh, so Alan, are you? Sounds like you have a bone to pick with the ideal gas law, or the
no,
something
I'm
related to
saying that when you're integrating it with the atmosphere, the conditions have already been set so that when you finally put in the radius value, it's going to exactly work out because that's how it's been designed. That's what all the papers that I sent you are doing that. So I look forward to you doing this process because your conclusion is gonna be my premise. So, and I don't mean that disrespectfully. I know you're going through the process, but
I'd
yeah,
be
you're
happy.
gonna.
I'd be happy for my conclusion to be your premise. I'm just like you guys. I'm looking for what I'm looking for where the evidence
Eh,
leads.
Yeah, if it could be done without a radius, which obviously assumes the shape of the Earth to integrate it, like the lads would have done it.
No, but shout out to you for trying to get first order measurements, man. That's rare to see. So that's it.
Yeah, I want to start where we all agree. Like, what is reality? But on the level we agree on, and then see where I can go with first principles and the mathematics that always work out in the real world when you follow them to their conclusion and you test them. Yeah, they work out. These are just very basic things. The ideal gas law, it works out. You can do these things at home. You can form an experiment and test the ideal gas law. So, you know,
Yeah,
using
and again, not disputing ideal gas law, disputing knowing the amount of air density, or I'm sorry, air mass required to make uh, to make it provide the spherical concentric shells that's going to be required if you do it without the ideal gas law. Because the two papers I sent you, one of them doesn't use the ideal gas law. That one was actually added in as a supplement to try and derive it, dynamically and first principles and all that. But ended up with the same exact scenario where they have to make several assumptions to make it all come together when they do the spherical integration, because it's not because the astronomical refraction models aren't about explaining like, oh, what's the weather doing, like how hot is it today. It's this star has to be at this angle specifically, in reference to where it should be, and this so this is how much refraction there has to be. So that's what the whole thing is based off of, the stuff that I sent you. And so even adding the ideal gas law, like that didn't change the circularity of what they're doing. So I'm so looking forward to you building your own thing and then going through this.
yeah, and I'll obviously show my work and how I got from point A to point B.
Yeah. Do you have a GitHub, and do you know what Jupyter Notes are? Because I started using Jupyter Notes in GitHub recently, and it's phenomenal for giving someone like some math and being like, here's how it all works, and then they could do it. They could execute the code themselves and stuff. It's awesome.
Jupyter Notes.
Yeah, Jupyter Notes and then GitHub, obviously, so you can just have a link to give to anyone.
I wonder what you would think of the video that I saw recently. I shared it before last week. It's a 4-video series describing the very thing I was talking about getting to the differential equations for x, y, and z. Of course, you can simplify it to just a 2D version, which is what he did. And the only thing that's a black box in that is the differential equation solver itself. So there may come a point where I'd like to go into the weeds on that and build my own differential equation solver, because I know it's just a procedural thing. The vast majority of differential equations can't be solved analytically. You have to, use some sort of numerical method to converge onto the answer. So it spits out a curve, and based on different conditions, he did a temperature inversion and showed how you can, I forget what is it called, ducting or tunneling of a light, get it to follow the curvature of the Earth. It's just a simple temperature inversion.
Yeah. No, and that was modeled out through his ray tracer, you said, or was he like doing an experiment to show it as well?
No experiment. It was just a ray tracer.
Oh, gotcha. Yeah, send me the video. I'll take a gandy. there was a phenomenon called the Novaya Zemlya effect, and that's when the sun is observed when it's supposed to be below the geometric horizon for the true position and also the apparent position. And so in the 1500s or 1400s, these lads were exploring in the far north at the 72nd latitude. And in February, the sun at the time was supposed to be 5 degrees below the horizon, and it was observed 5 degrees above the horizon. So there's, it requires 10 degrees of refraction and so on and so forth. And so this effect was like, it was long disputed. Like, did these guys really see the sun and all this stuff? And it turned out, yeah, they did. Otherwise, they couldn't have determined where they were at, because they ended up, they were sailing around and stuff. So in any case, they did, and then the effect was observed in other places, including the Antarctic as well. And then also, it happens all the time in San Francisco. Apparently, this woman on YouTube films a bunch of them where the sun lingers way longer than it's supposed to, but not to the tune of 5 degrees or whatever. That's like a real extreme case. But in any case, the ducting, if you were to ray trace that, you have to increase Earth's radius by 36,000. So six. What's the radius? 6,731 meters. Earth, no, a million meters. So clear, or 6,731 kilometers.
300 meters?
Well,
Is it 60? Is it? But in any case, you're multiplying radius by 38,000.
38,000 is the
38,000. 38,000.
see, here's
So
where
Wow.
here's where I'm not understanding. So you're saying that it requires increasing the Earth's radius.
To 242 million.
I do want you to check the video, because he didn't show how he tweaked the Earth radius as a parameter. He was adjusting the gradient of temperature only.
yeah, and that changes the effective radius of Earth. That the atmosphere, like the refraction conditions, is the effective radius. So the 42 million radius that Stone just said that he invoked was through making the conditions such that it would duct through it by changing the temperature and pressure along the path. So when we say it increases the Earth radius, that's what it means. So anytime you adjust temperature and pressure, that's adjusting the effective radius. So it's literally just curve fitting it to what it should be, or whatever would have to be. So it's like, if Earth ball, then to explain this effect, there must have been this much temperature and pressure inversion throughout the gradient along the path, and that's effectively making the Earth flat. So
Well, what's interesting is that even he did actually do a flat Earth model, and he showed light starting so many feet above the ground. I think he did 6 feet, and he went straight horizontal to the ground. And similar to what I was telling you about a wavefront going horizontal, it will curve downward. It'll curve into, like, the normal to the wavefront as a vector would actually start to curve into the denser part of the gradient. In other words, it curved down, and it showed the light ray crashing into the flat ground, which was really fascinating. So yeah, even on a flat Earth model, it would not get very far. It would only get so far, is what I'm saying. And
agreed.
yeah, so but anyway, that's all.
Oh no! It didn't show the ray going on forever in perpetuity, or whatever
No, it
people
did
like
not.
to say.
No, it did
Oh,
not.
that's so weird.
No, it's a really interesting conclusion. And like I said, if you go to first principles and you think of a wavefront as little wavelets along that plane, then yeah, the ones on the bottom propagate slower. The ones on top propagate more, and so then that creates this bulge at the top along that whole wavefront, making the whole thing start to face more and more downward into the denser part of the gradient. So yeah, just I learned something for sure.
Awesome.
I'll send that to you.
TY. All right, I am about to go eat some chicken from the rotisserie place where you get chickens that are rotisseried.
that would be the logical place to go.
That's right. That's be my first stop as well. I'd probably go to where they're selling the chickens.
All right, I'm gonna hop down, but should something arise, I can returneth. But you gentlemen have a good evening.
Well, you as well.
Later, brother.
He just say he might come back with chicken breath.
That's what he said.
Yes. Rotisserie chicken breath.
Hey, Alan, not to put rush here, but what do you think? Because I'm excited to see the outcome. What's your ETA on that Aries presentation?
Dude, so I've only done like one video where I edited stuff, and it took a while, but I think I can knock it out within the next couple of days for sure. It's like I just finished all the math stuff really, so it's just gonna come down to editing now. So that's my weakest point. So
Nice. The one thing that's bugging me when it's just the math part that's the beta, which is pretty much V over C, when they're talking about the velocity of the telescope that's the water that's moving supposedly with Earth, they do V equals beta times C, which is like saying V equals V over C, V divided by C times C. So it's like starting out where you, it's like you did nothing. You know what I mean? And I got
yeah,
go ahead.
they started off with wrapping in the motion while treating the Earth as it's at rest. And that's how they get away with it. They're just like,
Right. That's what I
it's
see.
little sneaker, they're little sneakers, dude.
That's like I got to be making a mistake. It can't be that retarded. So I'm so it seems like it is. So I can't wait to see it, brother.
Dude, I thought that, and then I read the Wolfgang Pauli thing, read Franco's self-derived thing. I was like, oh, it is that retarded. It's as worse as I thought it was.
Nice. Hey, Jonathan, quick question. Foundationally, would you agree that effects themselves are antecedent to any coordinate system or frame that describes them, or vice versa?
Antecedent. I'm sorry. I'm choking on that word.
Meaning the effects themselves, right? That they aren't dependent on inertial frames or coordinate systems. What we described, the events themselves are antecedent. They need to be there first, not the coordinate system, right?
Trying to contextualize this, like it's very abstract what you're asking me, and I'm having trouble wrapping my head around it.
Yeah, that's cool, but that's pretty much the foundation, because they need to have their postulate not be budging, right? They need to have C. That's all runs down to C being invariant. So, what's all this physics based on? Is it based on coordinate system? Is my coordinate system different from yours, or is my reality the same as yours? You know what I mean? So that's the fundamental question. If you could answer that question, there's no reason why you should not be ending up here on this side of the fence. That's all I'll say.
It just sounds like something I've never thought of very hard. I'm still trying to appreciate the core of the question. Coordinate systems are just a way of being consistent with where things are. It's a ledger, if you will. And then events, we're talking about coordinate systems and time.
Yeah,
The coordinate systems
coordinates
of
is our way of
particles.
describing events, right? Time, position, orientation, etc.
Yeah, we describe events by where particles are at certain times and X, Y, and Z.
Right, and that'll
And
make
then,
things frame dependent. If you're starting off, that's your starting point. But if you understand that those coordinate systems are describing things that are real, you start off with what's real, then that is going to be what's antecedent.
well, coordinate systems are dependent on an object, a point of reference.
Oh, I agree. I agree.
So that reference has to be real and
Hallelujah.
referenceable. So I need to know. Okay, well, if I'm in a car, well, there's a 000 somewhere on that car that you assign, maybe to the front corner, the fender. I don't know.
Hey
And
man,
then
I
if
have
that
I have no
if
worries about where you're gonna end up. That's all I wanted to ask.
yeah, if that coordinate system is moving with the car, then you just need to be clear about that, and then you can keep track of where everything else is. Now you can either have a non-inertial frame, or the car might be accelerating. I'm just kind of talking out of my head now. I don't know if I'm even getting to the kind of conclusion you're looking for.
It's all gravy, brother. I have full faith in you. Where you been, Shane? Bro, I tried to look up one of your videos. Everything okay? You talking about the JQ too much? What's up with that? Your YouTube?
Yeah, no, I don't know. I think that I've been deleted so many times that if I'm found anywhere, they can just instantly delete me and call it ban evasion or whatever. And that's what this one got for. They hit me with an email. They were like, "We discovered that you were avoiding our policies with you were, actually it was like in collusion with other accounts, you were subverting our policies." And I was like, "Yeah, fair enough. Cheerio. Like I always am." Right. But then I was like, "Oh, the flat Earth only YouTube where I specifically didn't talk about Jews so that it wouldn't ever get deleted got deleted." And that was disheartening. It's like you got me again.
Bad plan.
Anyway, no matter what. Yeah. Well, I had already made big shoots and rumbles and stuff, so I was like, you know what? I'll keep this like 14th YouTube channel just for flat Earth. That was the point of that channel, right? But the only thing is, I named it Shane St. Pierre, so it wasn't hard to trace it or like link it to my previous transgressions.
I'm glad you're back, bro.
Yeah, dude, that sucks. I meant to go like I reference those videos all the time. I was like, yeah, I'll show you. Hold on, let me go to the. Oh, that's right. Oh, wait, well, actually, I put it on the. No, I just put the link. That's gone too. I go, hold on, well, I'll just get it from the. No, that was just in bed. Damn it! All right, it's so annoying. Because I also used it as like a backdrop to put videos out and stuff. So some of those are gone.
Just gotta archive everybody's videos now. Just gotta get in the habit of archiving everything.
Let's hear it for Rumble.
Stoner is probably like, you might as well come to Big Shoot and Rumble with Stoner.
I've never had a nuked account, not on any platform. I guess I'm not edgy enough.
Stone's a Fed confirmed. Not just kidding.
I don't know what that's supposed to imply, but
Yeah, for sure. I know a couple of guys at the top, I guess. So yeah. That's why I have so many subscribers.
Dude, not many people want the truth, and when they do, they'll like actively seek it. I think I'm learning that.
Yeah, it's like vampires on the sun.
There's a diminishing crowd of people who are like, listen, I want all the truth, but I don't want to do any work, and I want you to force feed it all to me, and I'm gonna be skeptical of all of it. So go get me all the truth, collect it up, and give it to me. Like, I don't think there's a group that wants that anymore.
Too painful.
Yeah. Well, like the people that are mildly interested are also like active on it. So they'll like literally seek it out and search for it. And that's,
Yes, all 85 of them.
Dude, how's Twitter been going? I've been decidedly absent. When we put the model out, I think I gained like 3,000 like followers or something. I was like, oh, that's cool. That's the first time I've seen it go up in like 2 years. And I was expecting to see him go away or whatever. As Twitter's been constantly messing with us.
yeah, it's still being Twitter, man. They stifle you.
2,300 again? Is this your 7th account?
This is my 8th account.
8th account, okay.
I mean, I've had it for a little while so far, so I might stick around. I don't know.
We're the same 3 haters that constantly report you. We're those fags.
Right?
Hey, man, if you get to 10, you're going to get the t-shirt.
Man, if I get to 33, that's when all the good stuff starts happening.
That's a totally antithetical rank. What rank of flushed are you? Versus Masonic rank. I'm a 33rd flush rank. I know everything about this platform now.
Hey, you doing pretty good, Shane. You got 12,000 followers.
But I was at 10,000 for like 2 years, right? And I was pretty convinced that it would never go above that no matter what. But that model, the
I've
moment
never
when we lost the model, it gave it a little bump.
I've never been at 10,000. I just got to 8.
I feel like you've been at 10 for a while. Oh, I guess not. Dude, what do you think B flat over here's lifetime count is? 7 accounts times 2,000 followers. No, let's see. What was your first what was your first account that got deleted, dude? When the first time?
Man, that was like 9,000.
Oh, really?
Right.
Just the average of where you're at now, 2,300 on 7, that's 16,000 just there. So yeah, there's room for anomaly, that's for sure.
Yeah, that makes sense. Right now, it just means you have like 2,000 dedicated followers that'll follow you through 7 accounts, which is pretty legit.
And that's awesome, man. I ain't gonna lie, man. If you follow me through 7 other accounts, you the real ones. Especially my haters. My haters, man. A lot of those 2,000 haters. Got to keep an eye on Brian, see what he's doing. I hate him so much.
No, they hate watch you. Like they hate watch us. Like literally go to all your spaces, listen to all your talks, and they just like thrive on animosity and envy and jealousy and like pride. It's so crazy.
Brian's over there denying the science that we say can't be proven. What? Yeah, you guys can't prove because you guys can't prove anything, right? Oh, did he leave? Did Jonathan leave?
Yeah, you did.
And they're over there saying science is you can't prove science, you can't prove anything. What? Why am I being hamstrung here, man? Why can't I challenge something you can't even prove?
I don't know. Where can I go to be? Where can I go to be reaffirmed that what I believe is already correct? Can someone make me feel better about myself real quick? Give me an attaboy. What kind of group is that?
Man, and the favorite one is when can you give me a math equation for that? I was like, bro, you and your math equation.
Yeah. I mean, like the whole point of relativity is you can describe, the tunnel to Narnia. It doesn't make any difference. It doesn't like the moving frame of the sun doesn't matter when you're trying to measure something in the earth. But like, just because you have math to describe it doesn't mean actually anything. Actually, I think relativity taught us the opposite of that lesson. Now that I said it, right? They said as long as you have math for it, anything is possible. Now we have black holes, wormholes, and Einstein-Rosen bridges. So yeah, that one kind of went the other way. Damn. Oh, math became reality, dude. Alan's first presentation ever.
I mean, it's ridiculous, and it's like they're trying to sell that too. It's like, bro, that's even. I mean, you don't even have to be a Mensa candidate to understand that's a bad fucking way to go about things.
Yeah, but by that, if you had the math equation to describe the speed at which Superman flew, then you could invalidate the existence of Superman.
Exactly. It's like, what are you doing, man? What are you doing? What are you doing?
You don't understand that from the sun's frame, Superman's only moving at partially the speed of light or whatever. So it actually makes total sense in reality.
You don't understand physics, Brian. You don't. You don't need a medium. Hogwash on the medium talk.
Dude, light's little BBs and particles called corpuscles that obviously travel forever through nothing. It's dumb that you don't know that.
Stupid flurf.
Like, how come you don't believe in concealing light BBs that transmit through everything infinitely, through nothing all the time, in perpetuity, infinitely?
Why don't you believe in light years? Why don't you believe in calculations for stuff we've never actually measured or gotten the size of stuff? Huh?
Dude, I found a video that I put out the other day of like some dude on TikTok who's doing good videos, but I think he picked an article from like 3 years ago, and they were like, "Is this a piece of chorizo or whatever?" Well, chorizo, which I think is a sausage.
Chorizo.
Yeah, yeah. I don't know if it said it right. And he was like, "No, it's actually Alpha Centauri, the Proxima Centauri by the James Webb Telescope. How come you don't believe in science or whatever?" And it was like, "Nah, that dude was trolling. It was totally a picture of a sausage. Y'all fell for it. Like, it was pretty funny. I was like, no shit. You know how, I guess that's damaging to the credibility of the scientific field when you got scientists running the Webb telescope putting pictures of sausage on Twitter and going, haha, y'all are stupid because you can't tell the difference.
I mean, anything they show you, it could be anything. It could be anything. All you got to do is use your imagination.
That's the magic of science.
It's the magic of science, man. We can make math fit anything we want, and we don't even have to tell you how we got any of this math and how it came about. But if you do this equation, that means the edge of the universe is 46 billion light years away. And that's a fact.
We know this because we philosophically rejected the evidence of Earth being at the center and then forcefully reinterpret all other evidence as the Earth ever expanding as to avoid the conclusion that we were at the center. That's how we know that. There's some Copernican principle in there for the lads.
It's like I can understand that when you're first introduced to this stuff and you're really not given anything else to compare it to, you might say, okay. But when somebody starts saying, hey, there's some flaws in this, and here they are, and you don't acknowledge them, I don't know what the thought process is on that. Yeah, that should be like science 101. Hey, we got a flaw in oh, oh, when it comes to cosmology, you can be off by what? 10 to 120th? Oh. Oh.
He's talking about quantum energy in the vacuum quote, I think, for that one specifically, but yeah.
Oh.
It could be failed to, we'll just be off by 10 to the negative 46 or 10 to the 46 power. No big deal, as they say.
Slight oversight.
I mean, when you show these flaws, I mean, I never even heard of 8 inches per mile squared till like 3 years ago. So I know they're not teaching it in school. This is what the curve rate should look like.
Did you not have like the realization as you went through school? Like, I don't know, I didn't have it until I was done. That to look back through school and like look at how this indoctrination posed as education the whole time. Like, I thought I was being educated, and I was clearly being indoctrinated. In retrospect, every step of my indoctrination was like methodically executed and effective. Right? You can trace it back and you think about it and you just start going through the steps and you're like, oh man, before I even questioned it, I accepted it, never even thought about it. Gravity, you made that, water sticking to it with like the globe in the school. And then you start thinking about every movie I've ever watched, every radio show, everything all the programming I've ever seen, it's so crazy. So crazy to start thinking about it. And then if you actually ask questions of any teachers, again, the same reaction as the Globers, right? It's not on the textbook, then I don't have an answer. Shut up and sit down, kid, or whatever. There's no need to actually know. Just this is what it is. And if you don't like it, then you get an F. And so, like,
if you don't like it, you get an F.
Yep.
But yeah, man. I mean, when did you figure out that they were like shaped like jails and use the same cafeterias and the same transportation and stuff?
Yeah, dude, that meme where it shows you like the bus shape, the bus is just like a different color, the lunch is the same table, the same food, the same everything. Just like, oh my god, schools are prisons. I had no idea until you put them side by side.
A
It was like, oh man,
finely arranged collection of hoops and doggy biscuits.
Got us all trained to be pack animals and group think and all this other stuff. They told us what to think, but not how to think about it. I mean, they got us early. And they convinced us that if you wore a white jacket or called a teacher, that, oh boy, you're an authority and we should listen to you. Never question you because you got the smart brains.
Yeah, surrender to authority. You don't know anything. We know everything. Believe the state. Surrender. The state is all knowing and all trustworthy. You should always trust the state. It's like, what? But yeah, I went all the way through college before I looked back and I was like, oh, that wasn't education at all. And then, like, reflecting on it, and going through some stuff, being like, oh well, they don't disseminate truth and knowledge to the masses and then stay in power and retain all the money. That doesn't make sense. So what they must do then is retain all the knowledge selfishly and then dole out indoctrination guised as education, so that and then I'm like, oh crap, that's what the school system was. Oh, that's what textbooks are. Oh wait, who funded the textbooks? Oh.
Oh, you don't want to pay those guys, dude.
Like, okay.
It's not that Mark, is it? It didn't come from some dude that said, I really want to take down America.
Yeah.
Oh, you're talking about the Schmuckafellers. I know those guys.
Oh.
Right? Hey, I got a whole bunch of petroleum waste from this other business where I'm a baron of and I desecrated the world. But how can I use my petroleum waste? I know. I'll call it medicine. And I'll make pills out of it and I'll sell it to all the people for, quote, health. But first, I'll buy all the patents for the natural remedies that I'm going to try and replace with my petroleum waste products.
Let's put it in the toothpaste. Yeah.
Oh, yeah. So those are the same people giving the textbooks and setting the agenda for what's being taught to children. And then you're like, okay, now I see everything that I ever did just was guided to make me a more willing participant in the slave system, right? Tying the matrix. You got to be a good slave. So you got to go to school, you got to get a mortgage, you got to go in debt, they got to own you forever financially. You got to forever be subservient to the system. You have to, do what the government says, follow the laws of the police or whatever. Make sure that that's in your grain, and make sure you sign a contract to pay you for your house for the place you want to live, and chase that for 30 to 40 years, depending on how good your credit is or whatever. And then we can get you on a perpetual credibility where we always own everything and you own nothing. Like, what a progression.
If you don't get a good job from your college education that you had to go in debt to get, you're not going to get a good rate on your house loan. So if you want to incur more debt, you have to first be in a significant amount of debt, obviously.
Yeah, but how are you going to get a job that makes money when all you got taught is to get into debt?
Speaking of airplanes, what's Dave doing down there? Is he trying to land a plane?
Oh no, don't go there.
Dave, I heard there was a plane flying around in all different directions trying to land at a different
was the wind
latitude
going
than what it
there?
took off at. What the hell?
We should get him up here, wind him up, and play him at a Glober.
See if we can't coax him on up here.
Dude, we gotta get him a globe lad to talk planes with.
Where are the Globies at, man? This is sad. Retweet the space, tag a globe. Where's Hap at, man?
Hey Shane, you're feeding back pretty bad there, man.
That dude owes me $500.
It's never me.
Right.
Dude, ask him to derive aberration in the moving frame and not the geocentric frame if he thinks stellar aberration proves globe move. I'll hold my breath or whatever, or like insert the meme of the skeleton waiting at a bench.
Can't have them both, bro.
Where you at, Hap?
Oh God!
Please don't bring him in here.
Yeah, don't be like Beetlejuice and say his name 2 more times.
Right, he's got it twice.
Putting that limit right now.
I want him, man. He's in the timeline talking stupid shit. It's like, get your ass out. He's all like, you guys can't explain this and that and the other thing. I was like,
that's his natural state, man. Like, it is less painful and frankly way more entertaining to stare at a wall.
It is. I ain't gonna lie, but still.
Tards are going to be retarded. There's no reason to wrangle all the tards purposely, right? You can just let them be tarded.
I mean, he's out there saying, oh, you guys can't prove or explain this, explain that, explain. He's like, bro, everything's been explained to you. To say that we haven't explained to you is just utter ridiculousness, and it's just, you can say you disagree, you don't understand, you don't like it, blah, 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 but you can't say it hasn't been explained to you. Stop. Oh, they got no answer for this. Oh, we do. We do.
Everything that dude does is just like a chirp for attention. He's kind of like a bird that just keeps yipping at you. Like no matter what you say or do, it's gonna keep yipping and yipping and yipping. And the more you interact with it, the more it's gonna yip. crazy.
Yeah, pretty much.
My living standard took a quantum leap when I hit the block button.
Dude, I blocked Hap like immediately from the first time I met you guys. We were like, hey, this guy Hap, and I was like, I read like 2 of his tweets, and I was like, retard, block, don't give a shit. And then you were like, I really started talking to him forever. Then like he's never said anything once until he just avoids, repeats. He's the most annoying, like dumbest base level argument that I've ever heard, and it's beyond boring. It's like it's nothing. Right? It's such a nothing that who cares? Who cares what he does or says? Like when he tags me, I just leave the conversation immediately. I can't. I think it's retarded that you can block someone yet they can still tag you relentlessly in fucking posts. It's really gay about Twitter or whatever.
Quite.
So I have to keep leaving conversations of people where they endlessly post about us, but whatever.
Well, you're only in that because somebody else was in there talking. Not that you got, because I got people that tag me too, but I got him muted or I had Hap blocked for a long time because he's just annoying. And he owes me $500, and I'm just tired of his. You can't explain stuff. It just got annoying. So
Gotta remember the old no longer follow that thread function. It's there.
Yeah.
Oh yeah, that too.
Yeah,
that too.
Yeah.
That too.
But they always do that. The global reset. They'll ask you a question, like you'll give like a perfectly eloquent, well reasoned, researched answer. They'll ignore all of it.
Objection
like,
overruled.
No one's ever given me an answer to this question, and they'll ask like the next flat earther right in front of you, and you'll be like, oh, okay. So it's not about you want to know; it's just that you want to appear to say. Okay, I understand.
It's like you didn't say what I wanted you to say about, and then it had to be a globe. So you're obviously wrong.
And you didn't answer my question, also. Then you didn't give me the right answer that I wanted.
If you can't give me that it's a globe, you obviously don't know that you're wrong.
It's so ridiculous.
No, it's the expression we need to meme them to death with. We should be putting out on T-shirts pictures of globies right next to it that says "Flat Earth can't explain X," because that's everywhere, every time. That is where they start, as if flat Earth is an entity that issues, truth to us or something.
Can't explain this, can't explain that. But what if we do explain it? What happens then? Well, then
who is this flat Earth explainer you're talking about? That's my question. Like, where do I find this guy or girl or something
like
or Oracle?
Magazine, or textbook.
Yeah, flat Earth explainer. That'd be a great one at the newsstand.
But dude, that's pretty much all of the flat earth.ws memes, right? Just the most basic generic, like, haha, like fraction exists, stars rotate, if you look up, it's a globe, dummy, haha.
Gravity, dummy. Gravity. That's how it happens. Have you not heard of gravity?
Have you never seen the sun? What's wrong with you? Dude, nighttime. At some time during the day, it's nighttime. How can you think the Earth's on a globe? You're so stupid.
You're so stupid. Why can't you see the sun? Well, how big do you think we think the sun is? I mean,
well, when the sun sets, I can go to a 2-story building and watch the sun set again. That can only happen on a globe, so.
Haha, stupid.
I like that one. I like that one. When they come up with their own like de facto proofs and they say them so confidently with their chests.
And that can only happen on a globe.
Yeah, like what? Who the hell told you that? Have you even thought about it for more than 2 seconds? What do you mean it can't happen? It can only happen on a globe. Do you understand perspective and luminosity and atmospheric and how atmospheric ducting works? You got atmosphere, you got refraction, you got visual layers.
Opacity. Yeah.
Yeah. You don't understand how anything works. Is there a visibility index every day that fluctuates, or is there not? Like what?
That flat pass can only happen on a globe. Are you telling me you don't think of what?
Yeah. Well, they just tell you that stuff, and then wasn't it Flat Earth Dave who put up a drone and watch the sunset and watched it just fade out? It was like, that's how it looks when you're up there. Like that. Oh, that's crazy. That can't possibly be. Like you edited it. No, it doesn't do that. It must be a fluke. It's like no, if you have the right conditions, that's what it does each and every time. And Stone's shadow thing also proved that, right? Conclusively, it sets well above the horizon each and every time. So,
well, they're really triggered when we quantify things. I think that's the key.
How dare you try to prove stuff? Science doesn't prove anything.
How dare you use the sun and not conclude globe? Everything that we have on the globe comes from the sun, and the Earth is globe because sun. So
You're using globe math.
Yeah, you looked up and you're using globe math.
Yeah, and I still got a flat result. Yeah.
And we still come up flat, bruh. Still come up flat.
All math is globe math.
2 plus 2 is globe
Yo,
math.
Shane. Wait, are you on? Yeah. I was talking to Doofis earlier on here, and he was like, "Yeah, so you did the celestial theodolite wrong because the Earth's a globe, and if your measurements turned out not a globe, you did it wrong."
Well, duh.
Well,
It's
naturally.
funny that he's actually stating the conclusion that all the other globers reached, but are too afraid to state plainly, because that is their conclusion. Oh, if you didn't come up with a globe, you did it wrong and you're stupid.
Dude, yeah, he confidently was like, "Well, you're fucking dumb then, because it's a
Well,
globe."
you're dumb. Because it's obviously a globe.
It's
Obviously.
like so if I externally test your internally consistent system using an independent reference known as a mountain peak, you're saying like that that's not, you can't do that.
That is the large consensus of what people think, though.
And the crazy thing about that, man, is, Dr. Heffron was a globie, Yeah,
I think
and he
felt
went out
bad
there to
for us,
try to
dude.
prove it was a globe by eliminating the flat Earth, and he came back and was like, "Well, I'll be damned."
He was a PhD globie working in that
PhD?
area of science.
Big brain
couple
globie,
books
man.
that
He had the
published
big
also.
brain.
Like that's his wheelhouse. And then all of a sudden he started to apply objectivity to it.
So I get how you guys, and I was there. We were all there. You're not even thinking about it. I didn't even know people were having this conversation until I was like 53 years ago, man. Somebody's all like, that just hit the firmament. I was like, what the fuck are you talking about? Now here I am.
Dude, I think Heffron felt bad for us because he was like, well, you guys are like misguided on your, shape mythology, but cool on the ether, and clearly you understand science, and this is cool. So I'm gonna help you guys out with some null hypothesis framework. It seems to be you want to argue that the absence of something isn't, doesn't need its replacement. So the scientific framework for that would be a null hypothesis. Here's how you're gonna frame it. And then he was like doing his thing, took it like one step further, and was like, look at the mountain over there next to my window. I wonder if I just get an old, get a little sea star, take a gander, do some basic trick. Oh, look at that. And then he did it like 12 times, and he was like, oh crap, look at that. And he was like, well, guys, look what I have for you. And then we didn't even realize that what it meant was that he was a flat earther until like the second presentation. We were like, oh wait, so you're like a flat earther? He's like, yep. We're like, oh wow, that was quick. Like that's the we didn't even really establish if he was a real glober yet, but he obviously was, and he felt bad for us having to deal with dog shit arguments and retarded people and no scientific framing. So he was about to give us the null hypothesis and then immediately use that to frame the celestial theodolite, which convinced himself to not be a glober anymore. The whole thing was like 2 months. It was such a quick thing to watch.
And this is one of the things that bothers me about the Glovers. I don't believe in the Van Allen belt. I only believe in the firmament. So when they talk about the Van Allen belt, it just goes right over my head and out the other ear because I don't believe in it.
Well, it's probably the magnetic field that we have. So.
You guys remember 2 weeks ago when I forget which globie was in here estimating about the Apollo missions and those wacky Van Allen belts, they didn't want to go through those. So they probably went around them, he says. And then I told him how to find the Horizons database and how to check out the angle. And I followed up last Friday with the result on that. You guys remember? On how there is an object to observer to moon angle data point that they plot from the point of liftoff to when they finally jettison the third stage on the translunar injection part of the route to the moon, where they, quote, leave orbit. That's the only vector they got from Earth to moon. And it's straight. It's straight at where they think the moon's going to be in a couple days, like we talked about, 25,000 miles an hour, yada, yada, yada. There's no, oh, boy, I bet they went around the Van Allen belts when you're looking at JPL's freaking database that says, nuh-uh.
Well, according to Jonathan, heat doesn't matter in a vacuum. So them being deadly is irrelevant.
Interesting. Yeah.
Which is why you call them deadly Van Allen radiation belts, because they're totally non-deadly. Because in a vacuum, blah blah blah, heat isn't a heat. It's not that bad or something.
Love their nomenclature choices. Here's one. You know how when we talk about the sun and its GP position on the Earth as it moves from tropic to tropic 6 months at a time, that we resolve those as the Tropic of Cancer and the Tropic of Capricorn, astrological references aside, that we have a fairly representative thing that relates to the constellations we're seeing, and this is how it goes, and on that date, they're this maximum and minimum angle. Do you know what they actually term the moon's limits in the same context, where it goes so far north and so far south? And that's actually a range, unlike the ecliptic orbital, that there's between 28.1 and 18.4-ish, I guess, degrees north that it goes, and south, oscillatory, like a very wide range and a very small range away from the equator. Oscillatory, that's the moon's path. Do you know what they term it when it gets to the maximum of that range? A major standstill. Just chew on that mentally, for a second. The moon's path, as it's moving, as its most extreme across its orbital path, its angle that you add to 23.4, it's 5.1, you end up at 28. You know what I mean? It's one of those. And when it finally gets to that extreme limit, they call it the standstill. And there's the minor standstill, of course, when you're subtracting 5 from 23. That's how you get down to 18. And yeah, great choice, boys. Great choice. So intuitive. Killed the room again. I have a nasty habit.
Well, you went way too far with an answer that's grounded in science for what people just wanted, a surface level, haha, you're dumb sort of question again, right? That's usually what happens.
Was I too meta? Maybe.
Well, I mean, like that's usually what all the people who ask the question, they don't want the answer. They don't want to actually know or learn. No, they just they want to laugh and say their thing. Especially when they invoke things like NASA, gravity, space flight, kinematics, dynamics, propulsion, satellites, rockets, etc. Things they know nothing about, but they know that you're dumb because you don't believe that or whatever.
Oh yeah. So did we hear from Tanks yet? Because we've got a bunch of new people in the room, I'm sure, who are ready to speak, like 4 of them. But I wasn't here for any of that.
He's a Discord, bro.
Oh.
We got Methuselah. What's up, Methuselah? Do we have other people in here?
I just wish that freaking Gary would show up when Alan's here, but he doesn't. I don't think he ever shows up.
Who?
Don't Beetlejuice him into
Gary.
existence.
No. We don't want no Gary. Seriously.
Don't go there.
I mean, I never seen anybody aggressively misunderstanding stuff than he does. He goes out of his way to be a retard.
You think? Aggressive offensive tardation as a strategy?
No, you didn't.
And you can shut him down real quick by just calling him a fucking cunt.
No, my problem is that he's a drunk and he's a sloppy drunk, and that there's no coherence in listening when he's drinking, and that I just have no interest in that conversation.
Man, I think it's so funny that I started calling him a drunk and everybody started calling him a drunk.
Well, no, I realized he was a drunk immediately, dude. I had this thing where I immediately hate people and I'm an asshole, or I immediately can detect people who are sloppy drunk and I don't like it. And one of those two things is true. I've recently, I've recently learned that it's almost always the latter, though. It's almost always people that are drunk that instantly annoy me. That I'm like, oh, I'm not really a dick. I just don't like sloppy drunk people. It's fine.
That Grok took down his answer that one. I can't find that anymore. And I asked it if there was any orbital velocity that Michelson-Morley, and you kind of bounced back and says, be careful there, Grok. That's not what the other AI says. That one's gone.
Yeah, well, it's very tricky to cite and source AI during online conversations when you're anti-mainstream, because it'll always back up the mainstream, especially with Michelson-Morley interferometry and the ether. If you're asking AI any of those things, no matter what you're asking, it'll seemingly always tell you, don't worry, Michelson-Morley just proved the ether," and it will go through like the Wikipedia basic nonsense stuff. So you got to be careful. And then like to even get it to cite things that I know it knows is true with the circumstances is in and of itself tricky, and it's pretty funny. So I don't doubt that people have a hard time getting Grok to admit the truth around those things, or that it has since revised its strategy to not dance around the issue, because like you got to know exactly what the specifics were to get it to admit that you're right, and then it will instantly forget and lie to you again.
Right? Oh, yo, I forgot to tell you, Brian. I'm glad you brought that back up. Shane's gonna post it. Shane's gonna post it for me in the thing. It's the American Moon documentary, and in there's a timestamp that goes along with it. If he doesn't post it, I'll do it in a couple minutes or whatever. But in any case, they go over the whole moon narrative from different aspects, and one of the aspects that they go over is the transcripts for the timing differences for all of that. And what you'll find is like they prove that they edited those. Like the ones that are now public record are not the same as the originals and all that. So I forget all the technical specifics on it, but yeah, there's ambiguity there, and it's in that documentary. So
There you go. It's a 3.5 hour documentary, and at timestamp 1 hour 35:50, it goes into radio delay and the editing therein. That's
yep,
nice. Good call out, Alan.
yep. And if the phone conversation isn't in the timestamp, just like flick through the video until you get to the part where the president's in the Oval Office. That's when they're doing it. You'll see it, and then just go
No,
back
it
from
is.
there. And they do the full review of it. And yeah, it's not what it appears to be, and you're absolutely right. It's full hoodly daddle. And how do you start speaking to answer someone's question before they even uh, before you could know what it is to start speaking? Like that's ridiculous.
Yeah, the radio delay listed at 1 hour 35 minutes 50 seconds.
Oh, sweet, perfect. It is on there. Yeah. So just go right there, and your whole argument's right there. You can take screenshots of the transcript stuff that they did with the timestamps and all that. So it's good. It's good stuff.
Yeah, that post has an excellent index for timestamps and cataloging. So, like any topic you want to look on that post, it just instantly go to the timestamp. It's got very accurate. It's really nice. Yeah, that one documentary convinced me, dude. I watched all of that, and I was like, well, damn, that's like 28 reasons or whatever right in a row that are really compelling. Yeah, that one documentary convinced me, dude. I watched all of that, and I was like, well, damn, that's like 28 reasons or whatever right in a row that are really compelling.
You didn't watch him right there, Shane. You should have came back with "We totally went to the moon and played golf." That should have been your conclusion.
Yeah, I don't know if there's any actual debunks about this 3 hour in-depth documentary, and it's not even like there's other 3 to 6 hour documentaries going over shadow and interplay and cinematography and stuff that don't even focus on any of these points, that make a whole bunch of different points about
Which
how
one
it's
is that
impossible.
you're talking about?
I don't know. I gotta find it. I think Witsit brought it up one time. It's like a 6 hour like feature film about all the angles and shadows.
Well,
Yeah,
what's the
maybe
3 hour
control room.
one? What's the name of the
Oh.
3 hour one you were talking about?
So this is American Moon, and we put it in the hill, and I put it in the nest up top. It starts with a warning that says, "Don't put this on any social media platform, and if you do, we will strike you down hard." So that's pretty funny.
I thought you were talking about On the Way to the Moon, which I haven't really seen any debunking for that one either.
That's also a really good one. Yeah.
Oh,
Going
dude,
on the
the
astronauts
Wagon the
live.
Moondoggy one, I think that's the name of it. That's another really good one. That guy had some excellent arguments, and one of my favorites was in the LEM. They said that in space there's no gravity, yada yada. So to get fuel and stuff through a fuel line to get to an engine, excuse me one second, I got a cough. To get that fuel to go through the line and pump and all that, they had to have this helium tank in the LEM, this giant helium tank, and they were going to use helium to push it through, to push the fuel through. And so they ran into a problem where they had to remove that because they were going to take the rover. Now, to make the rover fit, they had to remove the tank, and you could see the schematics before and after. This guy has it cited in his book or website or wherever I read it. You could look at the pictures of it, and it shows the schematics, the helium tank and its purpose, and then they show the new schematics, and there's no helium tank. They they never replaced it or solved it or figured out how to square that circle or whatever, and just put the replaced it with the go-kart.
That is rather astounding.
Dude, isn't it funny that Jaron thinks we went to the moon now? He's not totally convinced as well.
No, he doesn't.
Dude, he
Yeah.
thought
Yeah.
he had a whatever talk with McKeegan, and now he says there's plenty of evidence that says we did go to the moon.
Yeah, I'm pretty sure I heard him say that, dude.
I think I don't know. I think he hopes. I spoke to him a while ago, and that was like even after his conversation with him, and that wasn't his position
Well,
that he said to me.
he can't be doing it for views. He's not getting that many.
Dude might be trying to stay out of jail for crypto scams, man. I'm considering that now, man.
I mean, if he was crypto scamming people, though, we could trace the wallet stuff. Like there'd be evidence of it. Is that a thing that happened?
No, I'm just spitballing. I heard something about crypto scams. Who knows?
Nah, that's dog shit. The crypto things are all public ledgers. If there was shit like that, you could track it. Like a good instance of tracking stuff. So the McToon challenge for $10,000 for finding a star or some shit or whatever it is without using latitude and longitude. So he put that money in crypto in a wallet or whatever, and then immediately, words are hard. Then he immediately took it out and like transferred it to different wallets and all that. And Jaron tracked it through, through the public ledger stuff and pointed out that the money's not even, it was the money that was once there is no longer there. Has no meaning. It's not a real thing. But anyway, yeah, all that stuff's public. So if he was doing stuff, people would have evidence that would be easily presentable for that.
Yeah, but he was like the anti-NASA guy, as far as I know. And then now he's like, oh, you know what? I was just playing. We definitely went to the moon. I had this interview with one guy this time, and now I'm totally convinced.
Yeah, that's a little much.
Good, all right, because pretty sure that's how it
The,
went
the
down.
only the only reason I'm defending it is because I talked to him after that had happened, and that wasn't exactly his position, and I wanna believe him because he was I knew him for so long as my friend, so I still think of him that way.
But that would mean that he's like pretending to have a public position to support the moon landing, but privately still disagrees with it, which I don't see in his current predicament any reason why he would do that. But whatever, I don't really care. as I was explaining it, I realized I don't really care.
Yeah, we'll never know, and it doesn't really matter. To be honest, to be honest.
But the moon is definitely one of the easier things. Like we definitely didn't go, right? And now they're like, no, we're totally going back. And it's like, yeah, but we didn't.
What's really cool about the American Moon documentary is, you know how everyone's like, "Oh no, I'm a photographic expert, and here's my conclusion for how the shadow should be or whatever, and how the radiation should affect the film and whatnot." Well, in the American Moon thing, they also got some professional, big name photographers, and you can like look up those people's names that were mentioned in it. They're professional people that shoot for magazines and stuff. Like they're very familiar with the camera and lighting, and they break down like their opinion on it, and their opinion didn't agree with what the quote unquote experts that believe in it go with. So like who do we turn to when the experts disagree? Like you can just say whatever you want, really, apparently.
Well, you pick your favorite expert, and then you ostracize the other experts, and then by de facto, your experts are right.
It's like if no one can agree, then the evidence is not something that can be used.
Yeah,
That's why Globers only ever talk in single units. They don't ever pair up because they know they're going to contradict each other.
Well, see, they don't really, though, because they all have the same dogma and the same script, and they can only answer the same questions in the same way. They seldom contradict each other. You can get them to do it.
Well,
then they won't acknowledge it.
In theory, what you're saying is true, but in reality, they're not that smart, so they don't know the dogma they're supposed to believe in. So I think they are worried that they will say something different than the official answer.
Yeah, some of them just make shit up. They don't really care because it doesn't matter. They just know that you're wrong. So therefore, whatever I say is righter than what you're making up.
Exactly. Yeah, that's their main drive. They don't really even know their own science. I mean, some of them might, like Red's rhetoric, but the usual dude probably doesn't.
Oh, I found
Yeah,
another
I'm
one.
not sold on Red's rhetoric knowing anything.
A funny thing happened on the way to the moon's a good one. I'll put that one in the nest too. I think this one's on Rumble, but I put it on Twitter too. It's a really good one showing how the astronauts lied or whatever, just for funsies or unrelated, unrelated to whether we went or not. We did fake the picture.
Wasn't that like which country? Because wasn't that like something different from an American company doing that?
I put that up in the nest tonight. It's up top.
But like, I mean, my point is, I think it's a foreign film. The point is like everybody's always like, oh, why didn't Russia, blah, blah, blah. Like other countries are kind of like making fun of the moon landing. I mean, the evidence is out there.
Every time they say, "Why Russia would give us up," they would. Why? Why would you? What? They're the ones that started it. They went out there into space first.
Yeah, they have so much connections to the ISS. Like they're obviously getting a cut. They know how things work. They're like mob territory. They're getting their cut, and they're not saying anything about it. But some Russian scientists have been like, oh yeah, it's all fake, obviously. So put that in your pipe and smoke it. Direction, like the four basic elements, but now I get why you said we're burning dirt. Like sure, we're burning earth. That is a natural element.
Yeah, that's where all the credit goes to Earth, but they say that it's the universe. They'll give credit to the universe, some kind of I don't know, heliocentric or whatever model they want to give to the universe, and they'll say the universe is what gives us this potential, this energy, E equals MC, what all these things, but it's just the Earth, and they're lying. It's just a lie because the universe, whatever they imagine that abstraction of the universe to mean, they're not getting any of that from the unit. They're getting it directly from Earth, and they're lying.
And that's why I hate I looked up on Google flat Earth just to see what the definition of it was, and it said a pseudoscience. But like what you just said is our concepts are grounded in the earth, whereas their theories are grounded in, the limits of black holes in outer space. Like that is such a lie to say that, the globe model is the mainstream science and we're pseudoscience. That's the real like pin of their lie right there.
They can't even say anything that's pseudoscience about, the flat Earth, which just means it
Just like
doesn't turn into a ball.
Yeah, just like he pointed out, they don't even have a working definition. I mean, there's no working definition of flat Earth. You look it up; it says it's a thing that's been debunked. What is the thing? But what is the thing that's been debunked? Well, flat Earth. But what is that? Oh, that's a thing that's been debunked. What kind of definition is that?
Yeah, it's terrible. And I mean, like, I do use AI for certain things that I know it can be factual with, but with flat Earth, it has such a bias and it's up against such theoretical astrophysics that like it has no real way to like prove or disprove. They could be like, well, they tested this black hole and then they proved gravity. You're like, well, like how can you even, disprove that? But it's, I mean, not even
Well,
AI.
easily,
I was
easily.
just going to finish by saying
You
like,
just show. Yeah, yeah.
yeah. No, I was just going to finish by saying like the whole society is brainwashed by this theory, and it's so hard for them to overcome it.
Dude, I mean, seriously, they want to sit there and tell us that motion is relative, but then take a preferred position and say we're orbiting the sun. But if you tell me that motion is relative, that means you can't even tell that we're moving. How do you know that we're going who clocked us going 1,000 miles an hour if you can't even prove that we're moving, but we're spinning on our axis? How are you coming up with these numbers, man? And then we're also orbiting the sun at 66,000 miles an hour and chasing the sun at 500,000 miles an hour?
You shouldn't even grant them the conversation. That claim, right? That all motion is relative, and you cannot establish a like an inertial frame, like an absolute frame. That is an equivalent statement to saying that it's absolutely true that there's no absolute truth. They've removed themselves from the conversation. They should never speak on motion ever. They're not allowed. They don't know what's moving. They've removed themselves from that conversation.
And then you ask them what do you ever see moving, and it's like you only see the stars move, the sun move, and the moon move. What else you see moving? Nothing. I mean,
No, it's dogma. It's axiomatic and dogmatic. Their response would be everything is in motion. Well, when have you ever seen everything in motion? They'll say, well, never, but dogmatically, my model asserts that all things are in motion. So, but what's the proof of it? The proof of it is their dogmatic model. They've never actually seen all things in motion. It's just asserted through a model. So that, and then through that, they can't tell what's moving, what's not moving. Therefore, they've removed themselves from even having the conversation. The audacity to make the claim that the Earth is moving around the sun is moving around this other thing, while simultaneously claiming that there is absolutely no absolute frame of reference to measure motion against, is just dishonest. And dishonest and an attempt to never come to a conclusion. And they like that. That's what they don't want to. They don't want to. They don't want to come to a conclusion.
they gotta have that door just to jar, man. They can't. You got to give them the wiggle room, man. They need that wiggle room. So if they get caught in a corner, they can get out of it. So, but I got this equation that says we can shrink the interferometer and prove that the ether doesn't exist. We got the math, man. We got the math because we left the door open a little bit.
I also say, because I know they push this hard, like they claim to be champions of geometry. I think they actually suck at geometry because, a sphere is curved at all points. Like they don't even like understand that basic concept. So, anytime you see like a glober being like, oh, geometry, like, dude, they suck at geometry.
That was going to be my point that I interrupted with earlier. you can easily disprove gravity because gravity would dictate that the surface of Earth or the surface of water at rest should curve at approximately 8 inches per mile squared. So if gravity is, as they say, it is radial to a point, then the surface would curve. The surface does not curve, therefore the gravity is not radial to a point. It's easy to disprove this gravity thing.
Yeah,
And then
it's pure ghost physics.
I mean, you got Newtonian gravity, which he gave up on. By the way, it's true, he did. But in Newtonian gravity, you got the apple there falling on Newton's head after it breaks away from the tree. But in Einsteinian gravity, once the apple breaks away from the tree, it's like sitting around in space time, just hanging out. And the Earth and Newton rose up and bounced their head on the apple. So, I mean, those are two different kinds of gravities, but somehow, some way, the equation for gravity works out for both of them, which tells you that neither one of these two theories works for the equation.
Well, either one of those theories stands on the back of a of a globe measured with a radius of 3959, which dictates the surface of water at rest would curve.
No,
And
they just
since
go
it's
thing fall,
yeah.
therefore it must be gravity.
Well, I mean, the gravity just
Reddit said that.
is it just parallel to the plane of the horizon? This gravity? I mean,
But if you actually look at the word gravity, you know that comes from the word gravitas, which means weight, and you change that G to a W, now it's just the weight. Now it actually makes sense. You can work with that.